Hello and welcome to the 2019 Actual Tech Media Converged, Hyperconverged, Composable Infrastructure, and Integrated Platforms EcoCast event. Today is Thursday, January 17th. Thank you so much for joining us today on this special EcoCast event. We're excited to be joined by today's presenters from DriveScale, Hewlett-Packard Enterprise, Nutanix, Pivot3, Western Digital, Pure Storage, and Robin Systems. My name is David Davis, and I'm excited to be the moderator on today's event. I'm a 10-time VMware vExpert. I've been in the industry a long time, writing, blogging, speaking, creating video training, and I'm passionate about innovative enterprise technology, especially being a former IT manager and system administrator myself. Today's event is produced by Actual Tech Media, and we at Actual Tech Media created the EcoCast and MegaCast event series to help educate the world of IT professionals about the most innovative enterprise-grade technology solutions available to you today to help you to learn as much as possible, to get all your questions answered, and do it all in one online virtual event. And while you're learning, you have a chance to win some very cool prizes too. On today's event, you'll hear from 7 of the hottest companies in this space today. Each presenter will speak for roughly 20 minutes, followed by a live 3 to 5 minute Q&A session. This event is not a competition between the presenters. There's no winner being selected here today. Again, this is an educational event for you. We've asked each presenter to focus on what makes their solution unique and to demonstrate how their solution will solve your real-world problems. Now, before we jump into it, there's a little bit of housekeeping here that I want to make sure that you're aware of. First off, I mentioned prizes. I'll talk more about the prizes and exactly how to win them in just a moment. But you should know that we have a lot of Amazon $500 gift cards to give away. So make sure that you stay tuned throughout the event to be eligible for those prize drawings. Now, I'm going to be asking you out there in the audience a number of poll questions, and I encourage you to answer those poll questions right in the slide window in your audience console. I'll be sharing the results of most of those poll questions with you so you can see how you stack up with your peers. So I have questions for you, but I'm hoping that you're going to have a lot of questions for today's presenters. I encourage you to use the questions and answers box there in your audience console to ask as many questions as you'd like about today's solutions that are being presented. And we have expert presenters and engineers lined up to help answer as many of those questions as we can. I'll be answering a number of the best questions that you send in during the live Q&A sessions with each of today's presenters. Now, we encourage this to be a social event, and we encourage you to promote it on Twitter. The hashtag, which I'll mention again in just a moment, is HCI EcoCast. I'll be monitoring Twitter throughout the event, and I'll be following and responding to just about anyone who tweets using the hashtag. So if you're feeling social, feel free to tweet good things, I hope, about today's event. And then finally, resources. We have 6 handouts available for you to download from each of today's presenters. If you look at your questions and answers box, just to the right of that, you see the word handouts. If you click on that word that says handouts, you'll see the downloads from each of today's presenters. Just click on each one and it will automatically download the PDF to your local downloads folder. And finally, I want to mention that the audience console that you're looking at today is kind of like a windowed operating system. So feel free to drag or maximize the windows in your web browser around so that you can best see the presentation. In fact, I encourage you to maximize the slides window. And that way, when the presenters share architectural diagrams or they do a screen share and they show you the interface of the solution or they play videos, all of which we'll be doing today, you'll be able to see those as clearly as possible. I also want to mention that this is a completely live event. We have people connecting to this event from around the world today, and we have presenters, I know, from Europe as well as the United States calling in to speak on today's event. And as you can guess, with any live presentation, things can and sometimes do go wrong. So if something happens, I encourage you to just be patient. Try a browser refresh, because 9 times out of 10, if you're having trouble seeing or hearing the presentation, a simple refresh on your web browser will resolve that. And if you absolutely have trouble that a refresh is not helping, feel free to post your problem in the questions and answers box, and I'll respond to you and help you resolve it as best as I can. Now, I mentioned we have prizes. We have 3 Amazon $500 gift cards. That's what we promoted in the emails for this event. That's what we talked about on the landing page. But good news, But for those who are joining us on today's live event, I have got some great news. We just added 2 more Amazon $500 gift cards to today's giveaway for a total of 5 Amazon $500 gift cards. So make sure you stay tuned for those. When it comes to being eligible for the prize drawings, you must be on the live event at the time of the drawing. If you're watching this event on demand, I'm sorry, the drawings have already occurred. Winners have the option to make a donation to a selected charity. Grand prize winners must submit an IRS Form W-9 to Actual Tech Media. We will reach out to prize winners after the event via email to deliver your prize, and the full prize terms and conditions can be found at actualtechmedia.com, or simply right now click on your handouts tab and you'll see the very last link on there takes you to the Actual Tech Media events website, as well as our prize terms and conditions if you want to check out the full legal requirements. Now, through the MegaCast and EcoCast event series, we have donated thousands and thousands of dollars to the selected charities that you see on the screen here, thanks to generous attendees on our events who win prizes and say, you know what, I'd like to help someone who's less fortunate. I'd like to donate that prize value to charity. So thank you in advance if you decide to donate your prize value to charity. I'm very thankful for the generosity that we have seen over the years. Now, social media. I mentioned the hashtag. It's HCI EcoCast for Hyperconverged Infrastructure EcoCast. I'll be monitoring that hashtag. Feel free to follow Actual Tech Media for the latest in enterprise technology, and also follow me, David M. Davis. I'll follow you back and we can chat about enterprise tech. Now, before we jump into this with today's first presenter, let's first do a little bit of level setting here. Every IT shop out there, no matter whether it's a large shop or small shop, is struggling to find ways to achieve greater efficiency, agility, scalability, the ability to do more with less staff, and to do more with the same IT spend or less spend in some cases. And it's convergence, hyperconvergence, composable infrastructure, and integrated systems that are going to help you to do that. But first, I want to ensure that we have a definition of exactly what these are, because I know it can be confusing for anyone who's new to these specific terms. So converged infrastructure operates by grouping multiple information technology or IT components into a single optimized computing package. So these components might be the servers, the storage, the networking equipment, and just as importantly as those components, the management software that manages, automates, and orchestrates this infrastructure. So you'll be hearing a lot about converged infrastructure today. You'll also hear about hyperconverged infrastructure, or HCI. Hyperconverged infrastructure has a more software-centric approach that tightly integrates the compute, networking, storage, and virtualization, and it leverages commodity hardware that's typically supported by a single vendor. And then you'll also hear about composable infrastructure. Typically, composable infrastructure is more of a framework whose physical compute, storage, and network fabric resources are treated as services. So with composable infrastructure, resources can be logically pooled so that administrators don't have to physically configure the hardware to support specific software. And here's my take on converged, hyperconverged, and composable. It has the potential to provide tremendous efficiency to your IT infrastructure. And that's why personally, I am so excited about the future of what these technologies are doing for IT organizations around the world. They're helping you and your company save time and money, as well as make your life easier as an administrator. And we all need that. And the end result is that you can do your job better and focus on what makes your company most successful. Because as you know, upgrading the SAN, provisioning LUNs, and patching the servers isn't what's really going to make a difference at your company and help your company to be more profitable or change the world. Now, as you look at these solutions, there's different approaches to all of these. So I encourage you to understand the pros and cons of the different solutions, and that way you can best select the solution that's the right fit for you and your company. And I encourage you to take time to fully test before you buy these solutions. Do a proof of concept. And I'm sure that all the presenters on the event today would love to chat with you about the possibility of doing a POC at your company. And with that, it's time to get started. We've got a great event lined up for you today. We're going to kick it off with some poll questions. All right, so first poll question that I'm going to pop up before I introduce our first presenter is on your screen right now. It's in the slides window, and it says, what percentage of your servers are currently hyperconverged, converged, composable, or running on an integrated platform? And later in the event, I'm going to ask you a follow-up question to this, which is in 12 months or a year from now, what percentages are going to change? How do you think this is going to change? I'm very curious to find out where people are right now with the migration to converged and hyperconverged infrastructure and where they expect to be or plan to be in the next year. So just make your selection there on the screen in the slides window, and I'll share the results of this poll with you in just a moment. Some very interesting results here. So let me go ahead and share the results of this with you. Hopefully you voted already. If not, get a last-minute vote in now because I'm going to share the results. And take a look at that. So 16% said they don't have any hyperconverged or converged or composable at this time. 39%, however, are between 1 and 25%, so they've done some. 10% are 26 to 50. 19% are 51 to 75. And another 16% are 76 to 100% migrated to some form of converged or hyperconverged infrastructure. So very interesting statistics. Thank you for voting on that. Watch for that follow-up question later in the event on where you think you'll be in a year. Now, our next poll question is on the screen. That is, what is your industry vertical? And on this one, you may need to scroll down a little bit on the right-hand side or make that slide window larger to be able to see all the different verticals, because as you can imagine, there's a lot of different verticals up. So I'll leave this poll question up here for a minute to allow you to check out all the answers. And again, I'll share this with you. All right, looks like most everyone has voted. Let me share the results with you of this one. And let's scroll down here. So we've got a lot of educational, government, state and federal government, higher education, K-12, a good percentage there. We've got 13% healthcare, 13% finance and banking, very interesting, 38% technology companies, probably not a huge surprise, 2% real estate, 4% nonprofit, 2% manufacturing, 2% retail, and 9% other. If you selected other, go ahead and just use the questions box now to type in what your industry vertical is. I'm curious to hear what verticals we don't have represented up here so we can improve this poll question for the future. All right, now I'm going to pop up another poll question. That is, how many people work at your company? Should be a pretty quick and easy question to answer. All right, so let me share the results of that poll question with you. Take a look. We've got very large enterprises on here. 22% are 10,000 plus employees, and all the way down to one-person shops, which are 16%, or I shouldn't say one-person shops, small shops, 1 to 25, and then a good representation all in between. So thank you, everyone who voted on that poll question. And then last question before I introduce our first presenter today, that is, what's your time frame for doing a refresh on your server or storage infrastructure in the data center? Do you have an immediate project, the next 6 months, 6 to 12 months, 12 to 24, or not quite sure? All right, now it's time to kick off today's Converged, Hyperconverged, and Composable Infrastructure EcoCast. I'm excited to introduce our first presenter. That is Denise Schiffman, Chief Product Officer at DriveScale. Denise, are you with us?
I am. Thank you, David. Hello, everyone. It's great to be a part of Actual Tech Media's Converged, Hyperconverged, and Composable webinar this morning. I'm going to be talking about composable infrastructure from DriveScale. DriveScale is the only company in the industry providing scalable, comprehensive, composable solution that's software, and it composes heterogeneous, low-cost hardware. Some of you may not be familiar with composable infrastructure yet, so I'm going to begin by talking a little bit about what's happening in the industry and what's happening in IT. And that really starts with the rise of data-intensive computing and data-intensive applications. And you can see them here. It's predominantly big data with Hadoop, NoSQL, massively parallel processing databases, machine learning, object stores, and object stores are, of course, structured, unstructured, and partially structured data. NVMe Flash, which we think is really going to take off this year, and NVMe Flash over fabrics. The ability to use these kinds of analytics to inform business strategy and streamline operations and identify fraud, even engage with customers in real time, many more applications that impact a company's trajectory, its competitiveness, its growth, is creating significantly more data-driven companies. And that's both cloud-native companies and enterprises across all industries. These IT teams in these companies are processing, analyzing, and storing more and more data and need to find seamlessly scalable and cost-effective solutions for both computing and storage. And trying to do that with today's technology is a challenge. Modern data-intensive applications are significantly more dynamic than traditional back-office applications. And when I say back-office, I mean things like ERP or Windows Exchange Server or systems of record such as an Oracle database. And I'm going to talk more about the difference between these types of applications and why data-intensive computing is driving the need for a change. And one of the big reasons is that the dynamic behavior of data-intensive applications stresses traditional infrastructure in new ways. The dynamic behavior really comes from the fact that each workload from each application runs quite differently. In fact, we have customers tell us that running the same workload multiple times, each time they run it, it runs drastically differently. And that is very different than a steady state application. Customers are having to think about their infrastructure with new challenges and issues. They're asking questions like, is the workload performance-oriented or latency-sensitive? Is the workload run daily or once a month? Will the data continue to grow, and at what rate? Is the data streaming in and being computed on in real time? These mix of issues and attributes, which can be very different for each workload, makes planning for the capacity requirements as well as the performance requirements very complex to do. This is especially true since most data-intensive applications are deployed today on direct attached storage inside the server, or what we call DAS, or DAS servers. These DAS servers are pre-configured fixed SKUs, meaning that the resources, the drives, and the compute are locked inside the box, captive. And since they are locked inside the box, they result in enormous waste. Resources are stranded across clusters and left unused. Compute and drive capacity are trapped inside the server and often underutilized. Servers can't be redeployed after a workload completes because the configuration doesn't fit the next workload. And while many applications require the performance of the latest CPU, more than 40% of spend is wasted upgrading drives at the same time as the compute upgrade when buying new pre-configured servers. In addition, when you buy new server SKUs to deploy a new workload, significant IT time is wasted in waiting for those to be delivered, in planning what is needed when the capacity requirements are not yet well understood, and then again, having to reinstall the OS, set up the configurations for the servers, and deploy the new application. So you lose a lot of time in deploying and redeploying or repurchasing these types of servers. And lastly, it's difficult to increase rack density and reduce data center footprint with these legacy DAS servers. Deployments are inefficient, they're slow to deploy, and they result in wasted spend. It's time for a change. It's time to dump DAS for composable infrastructure. Composable infrastructure is next-generation server infrastructure that provides the ability to flexibly create, adapt, and deploy and later redeploy servers using pools of disaggregated heterogeneous compute, storage, and network fabric. With DriveScale, you can dynamically create your own servers on the fly using our Composable software application. Just about any combination of compute and storage can be composed to deliver exactly what your application needs. Let's take a very quick look at how this works. So you have the pools of compute and storage, and through software, you can quickly create a set of servers and clusters out of those servers. And then when you're done using them, you can pop them back into the pool. Here's a little bit more detailed view of how it all works. We have the DriveScale Composable platform. And on the left, what you see are standard data-intensive applications like Aerospike, which is a high-performance MPP database, Hadoop, or an object store. Then you see the compute pool, which is essentially diskless servers or servers that are disk light. All you need is a boot disk in them or boot drive in them. And we put a server agent on the compute. That way we can discover exactly what's there and have all the data on those servers to help provide insights and trending information, as well as know the inventory. In the center, you see a standard Ethernet network. 10 gig, 100 gig standard today, 400 gig. The new standard speed coming this year, or coming to the data center this year. It's already out in routers. So there's more than enough bandwidth and speed to run storage traffic on a standard Ethernet network. On the right, you see the storage pool. This is what we call, these come in standard simple storage systems called EBODs, an Ethernet box of drives. These are very low-cost storage systems, and we put a small software load on them because they have controllers on them and they connect directly to the Ethernet network to translate the storage protocol to the Ethernet protocol. So we have NVMe to Ethernet and SAS to Ethernet. And we also provide the same level of discovery and inventory of the storage platforms. And then what you can do in software, again, is create your servers, mount your drives. An example, you might use Aerospike, mount NVMe drives over Fabric to the compute and cluster those together to deploy the application. In another example, you might deploy a object store of which you would use much less compute and have a higher ratio of drives to compute because object stores commonly have infrequently accessed data on them. And you don't want a lot of extra compute nursemating drives. You want to actually optimize that configuration. And you have total power and control to do that with the DriveScale platform. And what we provide is a very simple RESTful API, standard API, very rich, or a GUI, making it very easy for users to set up templates to deploy in a very simple and easy way. So the Composable platform is an orchestration platform, and it creates a high availability, high scale, and high performance solution out of low cost components. Core to the DriveScale architecture is high availability. We have patented load balancing technology that manages traffic across links and moves traffic if a link fails. The DriveScale solution scales seamlessly to over 10,000 nodes and over 100,000 drives today, and we believe it'll scale even further than that. Applications run unchanged. And really importantly, the DriveScale solution is very high performance, equivalent performance to direct attached storage in a server, even at scale. This is what we call a comprehensive composable solution. It's great to see that so many companies are talking about composability or adding the term composability to the marketing of the product lines. But it can also be confusing. Many NVMe storage systems are positioned as composable, but they are only half of the solution. They're the storage side. Blade servers are also positioned as composable. This is an all-in-one, inside-the-box solution with significant limitations and very high cost. Even some HCI solutions are now saying they are composable because they are adding more configuration choices or software-defined networking to their large integrated management stacks. None of these provide the benefits of eliminating DAS and recreating servers out of software. None of them provide the flexibility and adaptability at scale that you get from DriveScale. Here's another really cool function that we provide with the DriveScale Composable platform. You can replace a failed component without physically touching it. Let me show you again quickly in a video. So what you have is the pool on the upper right and the cluster on the bottom left. When a drive fails, another drive is just pulled from the pool and deployed, taking the place of the failed drive. You actually unmount the failed drive, remount the new drive. It happens seamlessly and extremely quickly with just seconds from our software console. This is also a valuable function when you're running a high-performance application and some of the hard drives start to slow down or they're showing too many errors. And what you can do is you can quickly replace them, copy the data, and continue to run at very high performance. Here's a logical view of the DriveScale platform. In the center, you see Composer. That's the core application. That's our orchestrator, manager, monitor of the servers and clusters. As I mentioned before, we have a RESTful API and a GUI in which you can create your own templates, but we also integrate with third-party orchestration or management applications. We also, as you see on the right, have a cloud-based service called Cloud Central, and that's for cloud-based administration for your audit logs, oversight over all of your deployments, upgrading software, documentation, and other administration functions. And at the bottom, a really important piece here is that you have third-party servers, networking, and storage so that you can choose the vendor of your choice, including companies like Dell, Cisco, Western Digital, Seagate, and many others. DAS creates a number of problems. Most importantly, it wastes a lot of spend. And these things are what DriveScale solves. We eliminate over-provisioning, we eliminate stranded resources, the operational burden, and wasted time of deploying using DAS. Let me show you a point-by-point comparison. So first, with DAS, you have fixed queues force-fit to the workload. With composable servers, you can actually choose one building block server and one building block storage system, EBOD, and then you can configure out as many different server designs as you choose. It gives you enormous flexibility. You can do one compute to 300 drives, one compute to 3 drives. You have that kind of flexibility with our composable platform. With DAS, you have a fixed ratio of compute to disk. As I just mentioned, with composable servers, you can design any ratio you choose for the workload, and you optimize it to the performance of your workload. In other words, in real time, you can benchmark your workload, see what it needs, and adapt in that moment to the infrastructure that fits it. With DAS, a compute failure takes your drives and your data offline. With Composable, you can replace a failed compute from the pool in seconds. With DAS, your compute upgrades require a drive upgrade at the same time because it comes all in one box. With composable servers, you upgrade your compute, but you leave your drives in place, saving up to 40% in just hard costs right there. And finally, with DAS, a component failure requires a physical replacement. You actually have to go to the data center and pull that drive. And we all know that lots of times the wrong drive gets pulled. In Composable, as I showed you, you can just with a click of a button unmount a failed drive and mount a new drive, just like that. And then you're off and running. So we really believe the future is Kubernetes. And DriveScale is a perfect match for Kubernetes. In fact, we're a certified OpenShift partner, and then that's a Red Hat OpenShift partner. And this is really important because what's happening with Kubernetes is it truly virtualizes compute. It's lightweight, and it's designed for unpredictable workloads. In the same way that DriveScale's composable platform is designed for unpredictable workloads. And in the same way, we create flexible, adaptable resources to support those unpredictable workloads. DriveScale makes it possible to dynamically utilize the infrastructure and optimize utilization of the infrastructure. And DriveScale provides automatically persistent storage to Kubernetes as requested. And what that means is if a compute goes away, it fails, and Kubernetes initiates the pod on a new server, DriveScale automatically brings up that storage volume and reconnects it to that pod. We also provide additional visibility showing which volumes are connected to which pods. Together, DriveScale and Kubernetes enable you to design what you need and scale and manage the infrastructure automatically, from the containerized application to the servers it runs on and storage it consumes. DriveScale makes low-cost storage both highly available and high performance in a Kubernetes environment. It supports the mobility and ephemeral state of containers. DriveScale gives you the agility to create and adapt the infrastructure you need, eliminating stranded resources, deploying application-ready infrastructure in minutes, disaggregating compute and storage to optimize your spend when you upgrade, overall reducing refresh costs by 44%, over-provisioning, reducing over-provisioning by up to 70%, and helping you reduce data center footprint by 40%. I often get asked, when does it make sense to choose HCI, and when does it make sense to choose composable infrastructure? HCI and composable solutions are designed for very, very different purposes. HCI solves a few problems that are common in enterprise IT back office application deployments, including standardization, productivity, and virtual machine sprawl. HCI integrates compute, storage, virtualization, networking, and security. And now it even integrates multi-cloud management. So it's a very large integrated stack. Scale is done by one integrated node at a time, and scale maxes out at 16 nodes. The HCI design point prefers local storage, meaning inside the box, so compute and storage are trapped, each an expensive, highly integrated node. HCI's objective is to modernize IT, but it's modernizing it for your back office or steady state applications. It's just not well designed for new, modern, data-intensive applications. In addition, HCI duplicates unneeded data management in the infrastructure because data-intensive applications have already incorporated data management into their applications, things like replication, snapshot, backup. So HCI doesn't really suit modern data-intensive applications and workloads. On the other hand, Composable is actually designed from the ground up for unpredictable applications like data-intensive applications. You can program and adapt resources to the needs of the application. As I just mentioned, you have this enormous flexibility as you put together your compute, storage, and network fabric to create these very flexibly designed servers and clusters, anything from 1 to 3 drives to 1 to several hundred drives, depending on the application and the workload, and giving you the ability to optimize your resource allocation to each very different workload. If you have a workload that is running infrequently, you may want to leave the storage in place, meaning you run the workload once a month. You want to be able to reuse that compute. There's no other way to do it than if you use drive scale. You can leave that data in place, detach your compute, drop it back into the pool, and then reuse that compute for another workload. When you're ready to run that previous workload again, you just reattach the compute and you can go ahead and run it. This is an ultimate optimization of all the resources you have in your data center. In addition, and importantly, it's really simple and really easy to do. The great thing about composable infrastructure is that we're just at the beginning. We started with composing compute, storage, and networking. And I'm showing you at the bottom here, we see a future where we can compose and will compose GPUs, FPGAs, memory, and more. And it will work in exactly the same way. Your ability to create your own designed compute infrastructure and run bare metal or Kubernetes containerized applications, and those applications will run unchanged or as is. So how can you take advantage of Composable today? There are many use cases that we support, everything from machine learning and big data to all flash. For Hadoop, we've added data placement awareness so that Hadoop always places replicated data in highly available places. For machine learning, DriveScale enables high-performance deployments that seamlessly scale with the demands of compute or growing data. For tiered storage, this is a really interesting use case. Using a third-party tiering application, you can actually support that with DriveScale and create these variable deployments within a cluster, deployments or configurations of servers, meaning you can create that hot data solution with your high-performance NVMe flash, the medium solution, which you might still use flash, or you might use high-performance hard disk drives, and then your cold data solution using slower, lowest cost hard disk drives. You can do that all using the same software, the same orchestrator within the same cluster. It really is that simple and with that level of variability. And for high-performance all-flash deployments, DriveScale really excels. We provide NVMe over Fabric today with NVMe flash arrays using 100 gig network fabric. And soon we'll provide NVMe over TCP, which will, of course, give NVMe very, very high scale. Come check us out at drivescale.com, and I thank you so much for listening. If anyone has any questions, I'm happy to take them.
Yeah, great presentation, Denise. We do have some questions here for you. So while I ask you those questions, I'm just going to pop this screen up here on this question up on the screen here that says, would you like to be one of the first to learn more about the DriveScale solution? So I'll just leave that up for everyone to answer. So let's see, first question here is from Henry. He's asking, at what RAID level does DriveScale work, or do you even configure RAID when you set up DriveScale? How does that work, Denise?
Yes, we do support unconfigure RAID, and we support many different RAID levels. So depending on what you need, we can support that.
Okay. And a follow-up question, what about like availability, like cross clusters? I mean, do you have the ability to set like the number of copies you want to keep, or number of nodes you want to always have available? How does that work?
So that's actually a really good question. So we, in the DriveScale platform, we don't do data management. So we don't actually manage the data replication. That comes from the application. So say a NoSQL database or Hadoop, they do the data management and replication. And we just support that, and we make sure that the data is placed in the high availability places. Another good thing to note is that we create highly secure clusters. So the drives are securely mounted to the servers, and the clusters are secure from each other. So we make it so that there is no seepage data or access across clusters. If you want to design your Hadoop to replicate data across clusters, that absolutely works. But that's a choice at the application level, not at the infrastructure or the server level.
Got it. Okay. And then here's maybe a little bit more, basic high-level question. Is DriveScale hardware or software or both?
So DriveScale is software. Another really good question. In the scenario where we're working with storage system vendors that have EBODs, meaning they have Ethernet ports on their storage systems and controllers on them, we put our software on their storage system, and it connects to the network, and we're an all-software platform. So that works really well. But there is a market of JBODs out there, which is just a box of drives and does not have any network connectivity on it. And in that case, we put adapter in front of it, and we connect to the JBOD using 12 gig SAS, and then we're able to connect that JBOD to the network using the Ethernet on the adapter that we have. So in that case, we do provide a small piece of hardware.
Okay,
but our objective is to provide the software solution, this sophisticated software solution.
Yeah, it's amazing what you can do in software. And then what about if somebody wanted to get started? Like, what's typically the first step? Do they do a POC? Can they create a lab environment? How do people do that?
Yeah, so the first thing we like to ask people to do is, get a demo of the system, get a really good feel for how it works. If you go to drivescale.com, you can see demos there, and you can obviously ask us. We're happy to give anyone a live demo at any time. And then when someone has identified the use case, the first use case they want to deploy, then we set up a POC, absolutely. And we have customers, during the POC, they actually benchmark their application, and so they know the optimized configuration that they want to compose when they get started. So the POC is highly valuable.
Very nice, very nice. All right, well, it sounds like a really innovative solution. Great presentation. Thank you so much for being on the event today, Denise.
Thank you so much.
For more information on the DriveScale solution, visit drivescale.com. Also, check out the resource that's available for download right there in your Handouts tab, and it's entitled The 10 Reasons. Actually, let me get to the top here. The 10 questions and 10 answers around composable infrastructure for modern applications. So make sure that you download that resource. And with that, it's time for the next presenter on today's Hyperconverged, Converged, and Composable EcoCast. That is Thomas, who is the Chief Technologist at Hewlett-Packard Enterprise. Thomas, are you with us?
Yes, I'm here. How are you?
I'm doing great. Thanks for being on the event today. Take it away.
Perfect. Thank you. And first of all, thanks for having me, and good to be here and talk a little bit about HPE SimpliVity. And what I'm going to do is just give a little bit of an overview what is SimpliVity and what are some of the key benefits that the SimpliVity solution provides. And then let's see what kind of questions are coming up. Really, when looking at HPE SimpliVity is Hewlett-Packard Enterprise's hyperconverged solution. And it's really providing a bunch of differentiators with the ultimate goal to drive better business outcomes. And the key differentiators that we believe that SimpliVity is bringing to the market is making it faster for the system admins to actually operate the system, making it cheaper for the organizations to run actually a hyperconverged environment, and at the same time reduce the risk within their environment so the business can stay up and running and operate. And ultimately what this all leads is leaving the business with the ability to make more money. And that is really what the business is all about and what they should be focusing on. They should not spend their time really fixing problems or working on optimizing their solution. They should really help as an IT department, the lines of businesses on actually driving additional business. So what I'm going to do is talk a little bit about the SimpliVity solution itself, And the SimpliVity solution itself is really what I would call the only true hyperconverged solution in the market. And what I mean by that is typically when we talk about hyperconvergence, we talk about computer virtualization and storage virtualization. A lot of the times you forget that there is actually a third leg on the stool, and which is the network. And what we have done on the SimpliVity solution, we have actually brought together compute, storage, as well as network virtualization in a single solution. And what this basically allows you to do is take the traditional stack, what you see on the left side of the picture here, that we're typically building in data center environments, and really collapse it down into a single or two-node configuration and run all that on just basically a very handy, easy-to-operate, appliance-like kind of approach. So what I mean by that is you're folding your servers, your storage switches, your storage architecture, your backup and dedupe capabilities, your WAN optimization, your backup software, storage caching, your SSD arrays, all really down into a single all built-in appliance. And then augmenting this with top-of-the-rack network management solution that is software controlled, and manage that all out of a single user experience. Now, you might ask is like, well, this all sounds good, but what I'm really going to be saving out of this, and what is it really going to do for me? And so what I'm going to do here is just talk a little bit about a study that actually was done by Forrester, and they looked at how are people spending their time in a data center. And what we see is, when we really look at that, is there's a lot of time being spent on boring tasks, I would call it, which is not the high-value task that a system administrator wants really to deal with. It's backup and recovery. It's about monitoring, troubleshooting, and remediation. That is where we're spending about 40% of our time on, or about almost half of our time. And what it leaves us to do is really focus very little on what actually really helps the business, which is innovation and new projects. Now, what we have seen for customers who actually have implemented SimpliVity in their environments, when we actually ask them how are they spending their time, what we're seeing is the amount of time being spent on tasks like backup and recovery, disaster recovery, monitoring, troubleshooting, as well as provisioning, patching, and config management significantly goes down, and really basically almost doubling the time they can spend on really driving the business. Now, you might ask me, like, okay, so this sounds good. How are they really saving time, and what really makes the difference out here? And what I've done is actually I'll show you a couple of examples where really you will see when you are implementing HPE SimpliVity with Composable Fabric as a solution, what this really does from a VM admin perspective. So typically when you add or clone a virtual machine in a solution, what you will need to do is you actually need to perform tasks on the Hyperconverged solution as well as within your network. In the case of the SimpliVity solution with Composable Fabric, there's actually nothing you need to do on the network. All what you really need to do is basically say, like, create VM, and it will automatically do all the rest for you. It will automatically configure your entire network configuration, including the access controllers. So this is what true hyperconvergence really is about. Similarly, when we are looking at, and I'm just picking the last one on these 6 examples here, when we are looking at end-to-end troubleshooting, what we see a lot of the times is people don't have end-to-end visibility. What I mean here is they have to go to multiple different tools and then jump back and forth between these tools and really try to figure out how is this related to that related. And what you, in a lot of the cases, you have your hypervisor manager, so either vCenter or System Center. You have your hyperconverged management interface. You have your network interface. And then if something doesn't flow, you constantly need to go back and forth and figure out, is this port connected to this, and so on. With HPE SimpliVity, with Composable Fabric, with that integrated solution, you actually have a central viewpoint. You are managing everything out of your hypervisor manager. So we call this a VM-centric management approach because it's, first of all about the VM, because that is ultimately the machine that is driving the workload and that we need to pay attention to. We don't want you to have to focus on creating volumes or LUNs. We don't want you to have to focus on creating access controllers, modifying them, and we don't want you to have to worry about any of the workloads or even workload events like a vMotion bogging down your network and causing bottlenecks within your environment. Ultimately, this should all be done by the background processes, and you should have a single point of view for that. And when I'm taking this last example here is what we see in these environments where customers have implemented the solution. They are actually able to reduce that time spending on these mundane tasks to really down to like half the resources, and then take the free resources and really focus on how do I drive really my business and how do I drive more value to the business. So what is the core benefits of the SimpliVity solution? So the core benefits, I would group them really in like three categories. The first one is, and I talked about this just a little bit, is that VM-centric management. First of all, you're managing the entire solution right out of your hypervisor manager. So in the case of VMware, you do everything out of vCenter. You don't have to go to a different UI. You don't have to go to a different screen. Everything is done here. And most of the tasks are done with 2 or 3 right clicks on the virtual machine. So your focus has to be the virtual machine because that is where the workload runs, and that is what you should be focusing on. Not having to jump around also keeps you focused really on that task that you're trying to complete. And everyone who has ever been in a network operations center is, you know that people are doing 5 things at the same time. That is just the nature of a network operations center. And so from that perspective, we want to avoid that people have to jump around and then make mistakes. The second thing what we have done is, well, it's not just about making the life simpler for the admin, but also how do we protect our asset, which is our data and our workloads. And so what SimpliVity has built-in resiliency, backup, and disaster recovery capabilities automatically without having to add anything, without having to manage anything separately. So what this means is you can actually build a fully HA cluster with SimpliVity with just 2 nodes. That means you have 2 nodes, you have full data redundancy between these nodes, and if one node completely goes down, you can continue operating your environment. Similarly, when we are actually backing up, we have a mechanism of doing actually full backups of your environment in very short time frames. We are typically guaranteeing our customers to perform a 1 terabyte backup in less than 1 minute. If you have ever tried this out in your environment, you know that this is normally not possible. The SimpliVity solution gives you that ability. Similarly, a restore in the same amount of time. And then last but not least, one of the core capabilities that we have built in there is data efficiency. Now, you might ask, what is data efficiency? What does this mean? So what SimpliVity does is actually SimpliVity has built in automatically always on deduplication and compression. And that is done automatically at the time of when data is created or injected into the system. So global deduplication always on within the system. The best way for me to describe this is think of you're putting multiple virtual machines in your environment that are all running the same Windows 10 operating system. There is about 95% of that virtual machine is about the same. So there is really no need for you to actually write this data over and over again. So what SimpliVity does, it actually takes the data, breaks it down in small chunks, and looks, do I have the data already globally somewhere in my environment? And if I do that, I don't have to write it again. I just have to set a pointer. And we're not removing, touching, or doing anything with any of these data blocks as long as someone is pointing to the data block. So it could be a backup, it could be a clone, or it could be the original data. As long as someone is pointing to it, we're not touching it. And if we're modifying the data, we're just creating a new block and basically writing that to it. And because these blocks are so small chunks, that gets you to an extremely high efficiency. Now, there's another very cool, nice side effect to that that actually some of our customers have experienced, and that is about protection against ransomware. Because what's happening is even if you get a ransomware attack where data will be encrypted, that will generate new data blocks that will be actually written in addition to that. So now if you have to go restore your old state, all the data is still there and is not encrypted because SimpliVity's file system is making sure that these data blocks are not being overwritten. And then you recall I told you can back up and restore a terabyte in less than 1 minute. So we have heard from customers that had ransomware attacks they were back up and running in 20 minutes because they just could restore, versus on some of their other solutions, it took them weeks to actually even get to the old backups and bring the systems back up and running. So a nice side effect that you're getting out of that. I talked about most of these elements here. There's just a couple of other things I want to talk about because I'm getting these questions a lot from customers is like, how do you protect data within your system? And so what we are doing here is actually we're using a mechanism of actually duplicating the data within a cluster and then on the nodes itself. So people refer to this also sometimes as rain and RAID. And what this really means is we're actually, as data is being brought into the system, we're writing it on two separate physical nodes for the resiliency of if we're losing one node, we have the full data available. And then within the node, actually, we are doing RAID striping so that even if we're losing components of a system, that system will stay up and running and actually serve you the data. The big benefit of that is even if you're losing a node, you will have full performance of your system because the data can still be served from a single location. We don't have to spread the data out and then recollect it and rebalance that in the background. So full performance here for your environment. And then the only other thing I wanted to talk about from the VM-centric management is one of the things that we talk about is not just managing this all out of vCenter, but also giving you a global view. What I mean by that is if you are running a distributed remote office, branch office kind of type of environment, this will give you the consolidated central view of what's going on in your environment. Where are your clusters? Where are your nodes being spread out? And you can actually take a lot of these actions with just a simple right-click directly out of the user interface and perform things like backup, like restart, like clone. And interestingly enough, when we talk about cloning, that is as fast as doing backups and recovery. So if you are cloning a virtual machine, SimpliVity can do this literally with the blink of an eye. And that is, again, taking advantage of the data efficiency layer that is built into the SimpliVity file system. Now, you might ask, like, okay, this all sounds good, but what can I really run on these SimpliVity systems? And so when we talk to our customers, what is the type of workloads that they are really running on these systems, we really see any typical candidate that you would imagine that is a typical workload in an IT organization. So this is things like standard databases or Office applications like Exchange or any of those things, or industry-specific applications. But we also see databases like Oracle, e-commerce applications, SAP, what people are running on there. And not to forget the original use case for hyperconvergence VDI. That is also a very strong candidate that we see coming up over and over. Now, in the case of, okay, so we talked about benefits, we talked about features, we talked about use cases, but so what is SimpliVity? What can I buy here? And literally what I told you is SimpliVity is an appliance. It's a combination of hardware and software. We're running today on two different platforms. Our core workhorse platform is what we call the SimpliVity 380. That is actually built on the HPE ProLiant DL380 server. That is the world's most selling server. And we're actually shipping every 11 seconds one server out of the factory. So when you think of that, this is the industry's most sold server. And what we have done here is we offer our customers a wide variety of choices on configurations for this server, anything from a very small storage configuration to a very large storage configuration with any kind of processor that you wish on the core count, as well as different memory configurations for your system, so to really optimize it for your workloads. But we also have introduced a second platform, which we call the SimpliVity 2600, and that is really a high-density platform that we have introduced into the market. And if you think of that, this is a 2-unit high server, a 2U high server that actually has 4 compute modules in it. So that is basically 4 servers into UI high. And the idea behind that is actually give you the ability to have a very compute-intensive workload in a very small form factor. And that is really the key benefit of this 2600. This is really density. If you have environments where you have space constraints, this is a perfect solution for those environments. So this could be anything in a robo use case. This could be on manufacturing floors or this could be anywhere where you don't have necessarily a larger data center environment and you need something that is fairly small. And then last but not least, one of the elements I wanted to talk about is that integration with that composable fabric. That composable fabric is, as I said, a top-of-the-rack architecture, and it is fully integrated in vSphere. And what it really does, it software controls the fabric components, and so that basically the top-of-the-rack switches that are cross-connected in a mesh architecture and will automatically adopt to the workloads and automatically sends the events. So it will actually look at compute lifecycle events. If you do a vMotion, a compute vMotion, if you do a storage vMotion, it will detect them and automatically make sure you have the right bandwidth and the most optimized path for this event to go. I actually had a customer tell me last week that in his traditional environment where he runs just virtual machines, he always has the problem if he triggers a vMotion event, he has to call up the network admin and say, like, hey, don't worry, the workload is going to go on the network to 100% because I'm just doing a vMotion. So don't shut anything down, just let it go, and it's going to be just like 10 minutes where I'm just blocking your network. That is not a good solution in a data center. Here, that will really basically make sure that the fabric is dynamically adjusted to these compute lifecycle or storage lifecycle events. And then last but not least, there is one additional add-on that I want to quickly talk about, and that is RapidDR. This is an add-on capability for the SimpliVity solution, and that is really all about how do you automate disaster recovery. The idea here is to basically automate the failover or the failback after you have resolved your disaster and bring the workloads back into the original site. It is a way for you to make sure that you fail over the systems in the right order, so like your databases first, your middleware after, your applications thereafter. Make sure that they all come up in the right way, and then you basically can actually operate your workloads. And all of this can be done then in the case of a disaster with just a few buttons. We all know that when disaster strikes, we're all nervous, we're all like very worked up, and we make mistakes. This is about automating, simplifying disaster recovery as a failover and as a failback. And so that really will make life a lot easier for system administrators as well as the IT staff. Now, we talked a lot about hyperconvergence, and this is all about the on-premise solution. So how do we really drive this within my on-premise environment? But as you all know, Hewlett-Packard Enterprise is a company that is a wide portfolio company. So we have various solutions out there in our portfolio, from standard servers to standard storage technologies, as well as the hyperconvergence. But what it really comes down to is when we look at where is the world moving is moving to a true hybrid IT environment. So we believe firmly that everybody out there in the industry will at one point have a combination of on-premise IT and some parts of the IT in the cloud. Now that poses a big challenge. How do we operate in an environment like this, and how do we make the right choices? And so one thing I wanted to quickly touch on is one of the promises that we as HPE have written on ourselves is we need to help our customers to simplify hybrid IT. And so a couple of things that we're doing here. So clearly we talked about simplifying IT in the context of hyperconvergence with SimpliVity, what I just showed you. Now you have also some workloads that most probably you will have to run on bare metal. And as we all know, hyperconvergence is not a solution for bare metal because you need to virtualize compute and storage and networking to get to true hyperconvergence. So what are we going to do with bare metal? We need a solution for that. And so that is where our composable infrastructure comes to play. That is basically allowing you to compose physical servers in the form factor of blades or rack mounts in a system that can either run virtual workloads or physical bare metal workloads. But this is still all on-premise. Now, if you are really going to a true hybrid IT environment, you will augment this with compute resources and storage resources in the cloud providers. If they're Azure, if they're AWS, if they're Google Cloud platforms. Now, the challenge comes, how do I manage this? And so one of the things that we're doing here is we're bringing something to the market which we call HPE OneSphere. And that is, if you want to call it a cloud management platform, that has the ability to give you the tools that you need to make the right decisions on where you want to place your workload. Do you want to place your workload in your cloud provider, or you want to place it in your on-premise platform. How can you make sure you have the right amount of resources available in either of them? What is the best cost factor for you? Is it cheaper to run it here or cheaper to run it there? That choices you will get with OneSphere will give you that full visibility of your cloud as well as your on-premise platform, and then giving you the right financial decision points of where and how to place your workloads. So what I'm trying to get to here is, it is not about just hyperconvergence or composable infrastructure. You really need to look this also at how do you really operate and simplify the broader hybrid IT environment, and that is how we're looking at the world and how we're bringing these various pieces together. So with that, I'll want to say thank you very much for having me today, and let's see if there is some questions.
Great presentation, Thomas. Yes, sir, we do have some questions for you. While we answer those questions, I'm going to go ahead and pop up this poll question on the screen that says, would you like to be one of the first to learn more about the HPE solution? I'll just leave that up there. So let's see, first question that came in, they're asking about is, let's see, just looking through some questions here. Here we go, this is a good one. What's the minimum number of nodes with the HPE SimpliVity solution, and where does it make sense to get started?
Yeah, so the minimum configuration that you need for HPE SimpliVity is a single node. So you can actually start out an HPE SimpliVity environment with just one node. Now, obviously, with one node, you don't have HA capabilities because if the one node fails, the one node has failed. But that is the smallest configuration size, and that will work for very small businesses or maybe for small branch offices where you can take the risk of a potential downtime if something goes wrong. For any other environment where you have critical data or where you need access to the environment, the minimum configuration is 2 nodes. So from that perspective, if you would ask me, I would typically say like 2 nodes is the recommended configuration to start out with. Then you can scale it up to as many nodes as you need to, but you can start with 1 node if you have environments that don't need HA.
Oh, okay, that's good to know. But a lot of solutions, you can't start with 1 node, so that's very cool. Here's a question that just came in you might have some insight on. Is there any information on when SimpliVity might run on Synergy? So
while legally I'm a little bit in trouble to give you an exact date, but we're working on this, and so you can expect this within the nearer term, midterm kind of future to happen. But we're working on it, and we're looking at bringing SimpliVity on Synergy.
Very cool. Very nice. Another question here. I've heard that it's possible to restore a 1 terabyte VM in 60 seconds or less. Is that really possible, and what makes that possible?
Yeah, so we definitely are doing, and actually a lot of the times it is significantly faster than 60 seconds. So what you have to look at there is really what is the underlying process on how we're doing our backups and how we're doing our restores. So we're doing this obviously within the SimpliVity ecosystem, and within the SimpliVity ecosystem we have the global deduplication and compression. So what this allows us to do is actually, as we're backing up the data, we don't physically have to move a lot of the data elements itself if these data blocks that are deduplicated already exist on the other target platform we're backing up into. So let's say if a site in San Francisco is backing up to a site in New York, what I literally have to actually only move to the other side is the small chunks of my deduplicated data that don't exist on the other side, as well as all the metadata. And with that, then I basically can, on the other side, restore my virtual machines. I also said before that we're not overriding any existing blocks as long as someone is pointing to the block. So if you have ever transferred a block, the block will stay on the other side until all pointers are deleted. So these blocks never have to be written. I can give you one example maybe from a customer to just illustrate that this is really true and how this is working. So we have a customer that is actually in the oil and gas industry, and they're running oil platforms all over the Gulf of Mexico. And we all know we can't put a fiber optics cable there to actually run online backups. So what they traditionally had done is they actually took a helicopter, flew it out to the oil platforms, put a drive into the system, copied all the data on the drive, and flew it back with the helicopter into Houston. which is not very cost-effective way of doing backups, especially also not very fast of doing it. What they are doing now is actually they have implemented SimpliVity, and they do their backup over a satellite link, and it was the only solution they had found that is actually able to do that. And that unfortunately put the helicopter flyer out of business, and he was very upset about that and said, well, now I can only fly people, and my almost daily flights got rescheduled to weekly flights. But the benefit for them is literally they were telling us, like, the solution paid with a single helicopter ride. And they do now backups over satellite link, and everybody who knows the satellite link and backing up that amount of data is what people typically will say it's impossible, but it is possible, and that is made because of the SimpliVity file system.
Very nice. Very cool stuff. That's all the time we have for live questions. There is another good technical question here I'll put for you in the queue. You might want to respond to that one. But thank you so much for being on the event today, Thomas.
Yeah, thank you for having me.
For more information on the HPE solution, visit hpe.com. And, of course, also check out the handout that's available for download right there in your audience console. It's called Power to the VM Administrator, HPE SimpliVity with Composable Fabric. So check out that solution brief. I'm sure you'll get a lot of good info from that as well. All right, so now it's time to award our first Amazon $500 gift card. And our first prize winner for that gift card is Chad White from Iowa. Congratulations to Chad White from Iowa. We have 4 more gift cards to give away on today's event, so make sure that you stay tuned for that. All right, and with that, it's time to introduce our next presenter. I'm excited to introduce Mayank Gupta, who is a Senior Product Marketing Manager at Nutanix. Are you with us?
Yes, Dan, can you hear me?
I can, yeah. Thanks for being on
Awesome.
the event. Take
Absolutely.
it away.
Thank you. Good afternoon to the people on the call. Thank you so much for the introduction, Dan. And to the audience on the call, I'm glad that you are interested in learning how to modernize your infrastructure. And so that's what I will talk about. Before I jump into the presentation, I wanted to give a flow of how I want to speak. So this is a slide. Yes. So what I'll do is first I'll talk about why infrastructure innovation is critical to organization success and why the traditional approach of making a data center needs to be updated. I'll support that with some industry surveys and results. And finally, I'll speak to the solutions which Nutanix provides and why it's one of the best in the industry and why it's catching up so fast. So that's almost the flow of my presentation today. Now, again, I see there are 210 people on the call, and one of the reasons all these IT leaders and business leaders are here on the call is that companies that don't constantly reinvent don't last. And I have some sobering statistics on the slide. And what is very important is that all IT organizations as well as companies have to obsess on how to reinvent. One of the things which Gartner actually found is that one of the top priorities of CEOs is growth. But a very close second on the CEO's priorities is the fact that they have to re-internalize IT and how to innovate using IT to reinvigorate and reinvent their organization. So I think for the people on this call, it's very important to realize that it's almost incumbent upon them to work alongside with their CEOs on using the IT organization and to propel growth in this organization. So it's very important, and I cannot stress enough how important is IT innovation to all organizations. But there's a but. And the but is that if you look at the traditional IT, the way traditional data centers are created, which have almost a siloed approach where IT infrastructure is built into silos, which is almost legacy, and which have storage from different vendors, you have servers from different vendors, then you have a virtualization solution, as well as a networking and security situation. And what ends up happening is IT gets in this vicious cycle of buying, deploying, managing, and troubleshooting this. Now, because there are different vendors involved, you have to troubleshoot with different vendors, you have different management consoles, and essentially what ends up happening is it gets very complex. in the same length, when you have to expand a similar data center, there's a large upfront capital cost, and plus you have to realize, you have to understand what would be the dependencies between these different silos, and it gets very complex. And what ends up happening is that the already stretched IT teams can do very little to innovate the business, and all they are doing is to keep the lights on. In fact, a survey which Nutanix and IDC ran found out that IT organizations with traditional data centers spend almost 80% of their time just managing infrastructure, which is pretty hard given the fact that you realize that their task is to improve business applications. And in this case, only 20% of their time was being spent on managing and giving applications to their business. So obviously we realize that this traditional approach to managing IT infrastructure is not working. So what do we do? So over the last, let's say, 5-10 years, what has happened is there has been a realization that we have a problem, and there has been a move to public cloud, right? And what happens with the public cloud is the benefits come immediately. The IT infrastructure realizes that now, with the public cloud, the applications can be deployed very quickly. They don't have to worry about large capital expenses because now you can consume bite size of infrastructure, and most of it becomes OpEx rather than a large CapEx. And further, what happens is the cloud only gets better with time. So this should have solved all the IT problems, or so we thought. What ended up happening is the public cloud, as we thought it, did not solve all the problems. And again, in a survey that Nutanix conducted along with IDC, one of the biggest problems with IT departments and business leaders found out is that they had to bring back applications back on premise. One of the reasons for that is that many times than not, they were actually going over budget, but there are also concerns about performance. There are concerns about latency. Now, things are in the cloud, so there is an element of latency which is related with cloud, and you cannot run mission-critical applications on cloud all the time. There are also concerns about lack of control when you don't have your own dedicated center. And as I already mentioned, there's a concern about cost. In fact, what has ended up happening is, again, in the survey, what we found is that 80% of the respondents have decided that over the course of a year, they'll bring 50% of their applications back on premise. Now, that's a big number. And if you project it for the coming year, this year, this number is only going to increase. So we have a fundamental problem with just the public cloud solution, and there was something that had to be better than this public cloud solution. Again, what we found is that essentially the only way to solve this problem is we'll have to create a balance between a public and a private cloud. So what is needed is essentially that for applications which are cloud native and which can reside on a public cloud, they are suitable to reside on a public cloud. But for applications which are mission critical, they need to be on a private cloud at your own local data center. And this is the way you can combine the ease of use, agility, and scale when you have something on your own private data center. Once you have this model, I think now the pitch for hyperconverged infrastructure comes in. So what is hyperconverged infrastructure? One of the ways you can look at a hyperconverged infrastructure is that, in fact, it's a software-driven infrastructure for your private cloud. What it does, it abstracts the private and public cloud into a single operating model. What am I talking about? Let's look at this, right? What essentially happens is by creating a private cloud, you can get all the benefits that you used to see on a public cloud. Benefits like software everywhere. You can have web scale engineering. Benefits which big companies like Google, Facebook, and AWS use for their own data centers. Now you can have some of those benefits for your own private data center. Now that's pretty cool. That's what people want to do. But there's another fundamental problem, as you would have realized, could happen. Now we can potentially create silos of cloud. You can have a public cloud, you can have a private cloud, And for those of you who have robo-locations or applications running on edge or IoT applications, you can have a distributed edge cloud. Now, a good HCI solution or enterprise cloud solution has to do one of the following. It has to make sure that it abstracts the infrastructure and it ensures that data is shared, data and services is shared across all these environments, right? So let me just do an animation here. So what a good enterprise cloud does is essentially creates a seamless layer between the public cloud, the private cloud, as well as the distributed edge. And what you get, what your organization gets, is a single operating model, and business stakeholders and application developers have access to move across all these clouds. That is the fundamental premise of a good enterprise cloud. Now, I told you my idea of what a good enterprise cloud looks like, but I wanted to also back it up by some industry studies and surveys. So here's a survey which IDC ran with over 600 customers, right? Asking them, why are you looking into go with an HCI solution and what do you want to get? And what they found out is that enterprise cloud delivers flexibility and consumption, and again, consistency across all these different silos of cloud. If you look at the survey and it talks about what were the main challenges that organizations were trying to solve. So this is the graph that I have illustrated on the right-hand side. So 30% of the respondents said that workload versatility was a big concern for them. A very close second was cost effectiveness. And I'll go into why it's so much more cost effective when you have an hyperconverged infrastructure versus when you have the traditional architecture. Time to deployment. Again, when you have to manage a very complex architecture, it's very hard to deploy and scale that, versus with an HCI solution, the time to deployment becomes much faster. So these are some of the concerns which our respondents found were on top of their mind while solving this problem. There's another very interesting fact which talked about what is the adoption rate of HCI? Are people actually adopting it or people just talking about it? So let me talk about that. What you're seeing in this curve is it shows the HCI revenue annual spend as forecasted by IDC. Now it has two curves in that, two lines in that. So the first one, which is the green line, was IDC forecast in 2018, the first quarter of 2018. And then the next line is the second forecast, which is in Q2 of 2018. And what you can see, and this is almost astounding for me and for a lot of customers to realize, is that in just one quarter, they had to update their forecast by 30 to 40% across the board. So definitely, HCI and its adoption across the board is increasing very rapidly. And there are several use cases for that. Gartner, which is almost a leading industry analyst firm, has publicly predicted that the number of workloads which typical enterprises will run on HCI solutions, so these are enterprise-grade workloads which organizations have to run. So Gartner predicted that these HCI solutions which are running will grow from 5% in 2017 to 20% in 2020. That's a 4x growth in just 3 years. That's an astounding growth. So again, what I'm saying here is that there is a huge adoption cycle and around HCI, and people are adopting this. So this is some industry numbers and validation by surveys as well as other customers. But now I want to dig a little deep into what is the Nutanix solution and why is it different from some of the solutions which are out there. So let me talk about the traditional HCI approach, right? While it's supposed to solve some of the problems, it still has complexity. So let's look at the block diagram that we have on the left-hand side. So if you look at the lower block, what it still has is you have a standard storage, which is the SAN here at the bottom, and now you have storage controllers, and they're connected to your compute over a network. Now, all this is sitting in a big warehouse, and on top of that, you are running your virtualization solution. This could be through different vendors. And then finally, your applications are running on top of them. So this is what many other HCI solutions look like. On the right, I have a Nutanix, what we call a node. And what this node does to a single node. And that's almost the beauty of what a solution provides. Once you abstract all this complexity into a single node, then scaling becomes very linear, because now the next time if I have to increase my storage or server capacity by, let's say, 2x, all I need to do is just buy some more nodes. So in this case, 3x, right? What is also happening is now, because it's a single node, you don't have to partner with multiple vendors for your SAN solution. The time to deployment immediately goes down because all you're doing is just adding these nodes. And you don't have to deal with multiple management consoles. That's a huge save that our IT department, that our customers have said that now the fact that they have to deal with one vendor and there is one control to manage all this, it's a huge save on their IT team. So that's a big benefit right there. The other advantage is that now you can use a virtualization layer on top of this and run your application. So as you can see, it's a much simpler solution than the traditional HCI approach which people have been using. In fact, what I would contend further, because with Nutanix, we provide you a virtualization software, AHV, at no cost, so you don't have to buy an additional license for that. So you can even remove that virtualization layer and run applications right on top of your Nutanix nodes. And the good thing is that you can still use your existing top-of-the-rack switches and your current infrastructure. So it's very easy to migrate and adopt this very simple approach of a Nutanix node. Now, what does this node actually have? So I wanted to share that with the audience because obviously there has to be some complexity. You need to have all these layers. So let me talk about what makes the Nutanix solution compelling. So what I've done here is I've broken that node into individual green boxes, which you can see here, and I have several instances of nodes here. So what has happened is that one reason that Nutanix has become almost the most popular hyperconverged solution in the market today is the distributed system architecture, which essentially provides our end users with unlimited scalability, high performance, and resilience. How do we do this? Let me talk about that. So if you look at that, each of these nodes has its own compute. It has its own storage. This could be a flash, it could be a SSD, and it has a hypervisor. Now, what is enabling this distributed system is what we call the HCI software, or what we also call as Nutanix Acropolis software. And what this software does, it runs in a user mode VM called the controller VM. So it's right here. And each of these nodes has a controller VM. And the beauty of the controller VM is that it creates a single storage pool using the direct attached storage in each node in a cluster. Now, I know that's a mouthful, so let me explain that a little slowly. What the CVM does, it creates a distributed storage fabric, all the DSS, and it seems to the outside user, it will actually merge the storage across all these nodes and make it look like a single SAN. So the DSS essentially creates a pool of storage as well as resources for the outside layer. And that's what enables you to scale at a very nice, right? So what the DSF also does, it completely eliminates the need for a standalone storage array like a SAN or a NAS. What DSF also does is that it distributes data and metadata across all the nodes. Now, let's say you have a VM running on a particular node. A copy of that VM would be stored on other nodes on the cluster, but for quick access and performance, most of that data would be accessed on the local node's copy. So that way you get very high performance, but in case this node goes down, we can immediately bring it up with a copy of that data, which is spread across the cluster. So that's the beauty of having a CVM, which is running on each of these nodes. So this is what we call the scale-out architecture, which essentially allows you to expand capacity by simply adding nodes. because adding the CVM takes care of the fact that you can add as many nodes as possible, and it will immediately distribute the data for resilience. We also get, as I already alluded to, you get data locality, and we choose the best VM and cluster so that you can have the highest performance. And you can grow as you need. So again, this is what is unique to the Nutanix solution, which we call the distributed fabric, and it enables a lot of resiliency as well as scale out. Now I know a lot of you are used to standard SAN, and there are immediate questions about what is the storage grade that we're talking about and what is the security. So let me quickly speak to that as well. Now, two of the fundamental requirements to replace almost a proven and legacy in IT infrastructure is the ability to provide enterprise-class storage. A lot of speakers, in fact, industry leaders before me have spoken about what is the benefit of enterprise cloud storage. And that is not lost on us. And we realize that if we want to replace the standard SAN and NAS solutions, we have to bring in those features in the Nutanix cluster as well. So today, the Nutanix Enterprise Cloud solution, it routinely replaces SAN and NAS storage by leading infrastructure vendors. And instead, we also at the same time, we also provide the rich enterprise class storage capabilities, which users are used to. Capabilities like deduplication, compression, erasure coding, all these things that you have become very familiar to using. Also security. As far as the security is concerned, Nutanix solutions are built on secure by design methodology, and we include some of the richest security feature sets which are available in the HCI industry today. So again, we have listened to our customers, and both these concerns about how the storage should be architected are already addressed. One of the other things which I already mentioned in the graphic before is the virtualization solution, right? So Nutanix provides almost a native virtualization solution, which is called the Nutanix AHV, with all our nodes. So you don't have to buy additional licenses for your virtualization needs. What we do is we popularize the KVM hypervisor, and we started that with the foundation, and we have enhanced that for security, faster performance, and most importantly, we have integrated that with the rest of our stack. So even our management stack as well as the core HCI stack uses the hypervisor very in an integrated fashion. So essentially what ends up happening is that we at Nutanix provide the HP hypervisor and a full virtualization management, which I'll talk about, which we call the Prism, with every HCI software and appliance deployment at no additional cost to the end user. So you don't have to manage additional licenses or procure licenses. Now, obviously what ends up happening is if you're replacing a traditional IT infrastructure which has so many components into one plane, the management console is very important. So we have a full cycle lifecycle management console called Prism, which allows for very easy deployment. It's very simple to manage. You get real-time insights on a dashboard, and you get the advantage of one-click upgrade. Now, because we are aware of versioning as well as the hardware, we take care of all the versioning dependencies, and through a single management console, you can almost do a one-click upgrade, and that's a huge advantage for the IT infrastructure. And last but not the least, it gives you the ability to scale without limit. Now, I'm on my last few slides. So obviously one question on people's mind would be what kind of applications we run. And definitely we run a gamut of applications, from enterprise applications like Microsoft and IBM, VDI applications, as well as SQL applications like SAP HANA and Oracle. So again, these are in each earnings report, we report the number of applications that we are running. And I'm proud to state that almost 50% of applications are enterprise-grade applications running on Nutanix cluster. And since our founding, we have led in industry in providing customers the freedom to choose the solutions that we want. So for the hypervisor choice, you are free to choose our native hypervisor, which is Nutanix AHV, or you can go to solutions provided by VMware or Microsoft. you can choose a platform. You can use a Nutanix platform, or we also partner with Dell, Lenovo, Cisco, and HPE. Even for the cloud, we create the ability to seamlessly integrate public clouds, including AWS, Google Cloud, and Azure, and as well, definitely the Nutanix design, which is our cloud solution. So this is almost my last slide, and I wanted to talk about that we are the undisputed leader in HCI, and this has been backed by Gartner as well as Forrester Research, where we are in the top right of the Gartner Magic Quadrant. And finally, to the business leaders and the IT admins, right? Here's the proof, and this is an independent survey which IDC ran. Nutanix was not involved in any. We just made the introduction, and the survey was conducted purely by IDC. And what they found, and these are, again, very strong proof points to what I'm saying here, is that the benefits of a Nutanix infrastructure were that our customers got almost 500% return on investment over a period of 5 years. They lowered the total cost of ownership by 60%, and they had just a 7-month payback period. Now, if you realize that IT organizations have been running for 5, 10, 15 years, to get a payback period of 7 months is pretty astounding. So again, it's pretty nice to see when our customers are watching for us, and we get to see numbers like this backing up. So this is my last slide. Hopefully, I walked you through why it's important to reinvent IT and how the Nutanix solutions can help you do so. And hopefully, you're at a point where you want to start your cloud modernization strategy. Thank you. Thank you, Dan.
Great presentation. We do have some questions here for you from the audience. While I ask those, let me go ahead and pop up this slide, which is a poll question. Would you like to be one of the first to learn more about the Nutanix solution? And I'll just leave that up. So first question that came in here, Donovan's asking about how do we get more information on new NAS solutions from Nutanix? What this reminded me of is the Nutanix AFS solution. Do you want to kind of summarize how that would help potentially somebody who needs to replace a NAS and provide file services?
Right, absolutely. So what has happened? So obviously, one of the ways we would do is we'll help you connect with our inside sales team. But on a higher level, what we are trying to do is, if you look at the blog that I had shown earlier, what happens with NAS is people have dedicated IT teams which manage NAS and NAS storage, and we have abstracted each of those NAS into a Nutanix node. So instead of managing standalone NAS and having dedicated NAS teams for that, now because it's part of that single node block that I showed you earlier, it's much easier to manage NAS. Now, we have heard this from some of our customers as well, that, hey, I have a lot of storage needs, or probably I have a lot of compute needs, right? So we do provide SKUs in which you can skew almost those nodes in, let's say, a storage heavy or compute heavy, but we do provide our customers the ability to pick and choose according to their own storage needs. So I hope that is that what the question was, David?
Yes, I believe so. Yeah.
Okay.
So here's another question. Why are people choosing AHV over vSphere or Hyper-V, like other hypervisor solutions? And are there any tools to help you migrate?
Oh, this is a very good question. It's almost close to my heart, right? So when we started with our HCI solution, and it's not lost on us that a lot of people, VMware actually created this virtualization solution. So we started with providing almost everything on EXSI, on the virtualization solution from ESXi. But the reason we pivoted to AHV is because we realized that once we start with AHV, we can connect that with our whole software stack that we have. So it becomes very easy for us to integrate with the management console, to integrate with the rest of the HCI software that we have. So while we support a lot of functionalities in ESXi, the support is much more richer for our native AHV hypervisor, and plus you don't have to pay a license for that, and that's the best part. It's coming with the HCI solution. So it's much better supported. It's in a much tighter integration with the rest of our software. So, and plus you don't have to manage an additional license. So it's almost a win-win-win for our customers, and our customers definitely love that. Now, as far as your last question, on how do we do this migration, again, we have a set of tools which help you migrate. And again, I'll be honest here, you can move from VMware to AHV, and we are transparent. If you don't like AHV, you can move back. So we have tools, it's called an extract tool, which helps you come to us, try it out, and see if you like it. And most of our customers love that solution and never want to go back. But if for some reason you want to go back, we help you go back. So definitely, we don't close any road maps. And as I said, we want the customers the freedom to choose, and we completely support that.
Excellent, excellent. I'm glad that you all make that easy.
Yeah.
Let's see, I think that's all the time we have for the live questions, but there's a couple of questions left there for you in the queue, some more technical questions. Really great presentation. Thank you for being on today.
Thank you so much, Dave.
For more information on the Nutanix solution, check out the handout that's available for download there in your audience console. It's the Enterprise Cloud for Dummies book. It's the full book, and it's by Actual Tech Media CEO, Mr. Scott Delo. So make sure that you download that handout, share it with your friends, neighbors, colleagues, family, everything. Anyway, great book. Make sure you check that out. And with that, it's time for the next presenter on today's event. I'm excited to introduce Mike Capone, who's a Senior Director of Solutions Marketing, and Keith Hagman, who is a Senior Technical Marketing Engineer at Pivot3. Mike and Keith, are you with me?
Yes. We are indeed, David. Keith, are you out there as well?
Yes, I am. Can you hear me?
Yes, we can. Well, great, David. Thanks for the introduction. And Keith and I are going to talk a bit about Pivot3's Hyperconverged offering today. And we're not going to take an attempt to do an end-to-end presentation. It's tough to do that in the amount of time allotted here. So my goal is to take and give you just enough of a broad overview, but then drill down on a couple of specific areas that we believe provide a lot of value to you in terms of building out your infrastructure with a hyperconverged solution. So for those of you who aren't familiar with Pivot3, Pivot3 is a hyperconverged infrastructure vendor that's been shipping hyperconverged solutions since around 2008. So we were at the very forefront of the wave of hyperconverged infrastructure solutions as that technology started to come about and mature. We have systems installed all throughout the world, and we are recognized by Gartner, Forrester, and then IHS is a video surveillance and security analyst, and I'll mention why they're listed there in a moment. So we're recognized by all three of those top analyst firms as being in the top tier of hyperconverged infrastructure providers. And why I list IHS there, and you see it referred to in the title of this slide too, with the modernizing hybrid cloud, meaning data center environments, and then IoT infrastructures. I mention that because Pivot3 has a long history providing hyperconverged infrastructure solutions, not just for data center-oriented use cases, but also the video surveillance and security arena. We have systems installed all throughout the world that are ingesting and storing video across a wide variety of use cases that I'll refer to at the end of this presentation. So we are unique from the other hyperconverged infrastructure vendors that you'll hear from, in that we have solutions optimized for both data center-oriented use cases and then solutions optimized for the video surveillance and security use cases. And we do see more and more IT infrastructure professionals not only needing to support application workloads that are supporting the traditional data center functions, but also starting to assume responsibility for the physical security, aspects of their companies, just because of the amount of storage, network bandwidth, and other sophisticated applications that are starting to get employed there, such as analytics. So kind of make a note of that in the back of your head that we do provide solutions optimized in both of those areas. From a Pivot 3 intellectual property standpoint and differentiation standpoint, we're recognized by the analyst as having a lot of differentiation in software-defined storage. We were one of the first companies to develop a software-defined storage platform, and as I'm sure you've heard from the hyperconverged vendors on this EcoCast, that's at the core of what a hyperconverged infrastructure solution is. It's all about software-defined storage. So our hyperconverged infrastructure software platform has at its core essentially an iSCSI block storage system, operating system that looks and behaves just like an iSCSI block storage device. We have a lot of innovation in a efficient and high-performance scheme for doing data protection. That's our own patent implementation of erasure coding that we've been doing since day one. I'll talk a little bit more about that towards the end of the presentation. And then what we're going to take and really focus a lot on today is our policy-based intelligence engine that is targeted at simplifying management of your hyperconverged infrastructure environment. So I'll kind of save that for a bit later. And then our hyperconverged infrastructure nodes are based upon a distributed multi-tier architecture that from day one, the software platform was designed to take advantage of first PCIe flash, and as it evolved into NVMe, be able to take advantage of NVMe. So we do have a lot of great areas of intellectual property that winds up playing into benefits for you as you deploy hyperconverged infrastructure solutions. I know there's been multiple vendors on this EcoCast talking about hyperconverged infrastructure in terms of what it is, and so I'm not going to take and go into that, but I do like pointing out a couple of things related to it. You see the stat here from Gartner. Hyperconverged infrastructure is one of the strongest growth categories of technology being deployed in data centers. It's a forecast to take and grow at a 48% compound annual growth rate over that 2016 to 21 timeframe. But even the more interesting part of that that Gartner has pointed out is by that timeframe, over 50% of the storage that's deployed in enterprises will be deployed on some type of software-defined or hyperconverged infrastructure solution. So that more than 50% really, to me, speaks to a popular way for enterprises to take and build out infrastructure to support their various applications. So this is a good spot to stop and do a little audience interaction. David, do you want to tee up this poll for me here?
Absolutely, yeah. So the poll question that's on your screen right there in the slide area says, what was or will be your most important HCI selection criteria? And choose your top 3 most important criteria. And I'm very interested to see the results of this poll. I know it might be hard to choose 3. I think if I were still an IT manager, I would want to select every box on there. But try to choose just your top 3. So I'll give you a minute to answer that poll question. I see some responses are coming in already. I was going to ask you to make a prediction, Mike, but I think you can see what the responses are before we post them. So
it's kind of like watching the Kentucky Derby unfold as the horses come around the track. Who's in the lead, who's catching up.
That's right. That's right. All right. Looks like most of the audience has voted out there. I appreciate those votes. I'm going to go ahead and share the results of the poll. All right, looks like the winner here was performance at 25%, followed by efficiency of storage utilization, 14%, actually followed by resilience, high availability at 15%, and then efficiency of storage utilization. What do you think, Mike?
Well, that's great. First off, thanks everybody for taking the poll. And it's interesting. I've done this survey multiple times now on previous EcoCasts that we've done with our friends at Actual Tech Media, and the results have turned out fairly consistent every time, with performance top on the list, efficiency, resiliency being neck and neck on number 2, and then we continue to see more and more quality of service popping up high on the list as well, and then scalability. So yeah, very consistent with what I would expect to see, and I almost feel like it's a little bit of a setup for what I'm about to talk about next, because in all of our discussions with prospective customers and our installed customers, we hear them talking about those type of things consistently. And I talked about just how popular hyperconverged infrastructure is becoming for your peers to take and deploy in their data centers. And in talking to them, early on, companies deployed hyperconverged infrastructure to predominantly support some targeted or siloed workloads, virtual desktop infrastructures, maybe a particular siloed database environment, business intelligence analytics, etc. And as companies got a taste for what the benefits were of hyperconverged in terms of simplifying operations by reducing costs, making management easier and such, and reducing the complexity from managing separate SAN, storage networking and such, they said, hey, this is working out great, but what I'd like to do now is I'd like to be able to consolidate more of my multiple mixed application workloads on hyperconverged, including those ones that I deem mission critical and that may be very latency and performance sensitive. And then as we talk to companies looking at making that migration from legacy infrastructure to hyperconverged, the type of questions we get are the ones you see listed there, and they kind of line up very well to survey results there. We see IT infrastructure professionals wanting to know, number one, is it going to perform for my applications? Number two, how can I ensure that I can confidently deploy multiple mixed application workloads on hyperconverged, because I want to reduce my infrastructure costs by consolidating more and more. Is it going to be efficient? Can I predictably scale it? And will it have all the sorts of data services and management tools that I'm used to having in my SAN environment? So we get these type of questions from people that we're talking to about hyperconverged, and I'm happy to say that we can work with people and check the boxes in all these cases. And that kind of leads into how do we position what Pivot 3 Hyperconverged can do for you. We've put a lot of engineering effort over the years into ensuring that we can deliver the performance that your mission critical applications require, and that you've got sufficient performance to support multiple mixed application workloads, and we do that through having the ability to take and aggregate resources from all the nodes in the hyperconverged cluster, if you will, into one giant pool of resources that all the VMs, regardless of what node they reside on, get the benefit of. We ensure flexible and predictable scalability. You can scale by adding hyperconverged nodes that add storage to the pool, as well as can host VMs, compute-only nodes, GPU-optimized nodes. We have a version of our software that actually runs up in the cloud, so we take and enable cloud connectivity for backup, DR, workload mobility purposes. And then from a resilience standpoint, from day one, we've used this patented implementation of erasure coding that can provide greater than 80% storage utilization, and that's before you do things like compression to it. Then when you do indeed suffer failures, it's able to take and retain over 85% of its normal performance, even when it's running, in those degraded modes. So we put a lot of effort, into ensuring that we can deliver, a high performance, scalable, resilient environment. But the thing that we've also put a lot of effort into from an engineering standpoint to make your life easier, from a system administration standpoint, is simplifying the management, with the objective of making it easier for you to deploy multiple mixed application workloads on this hyperconverged infrastructure and ensure that your applications are going to get the performance, the response time, the security, and the availability that particular application requires. And that's what we're going to focus a little bit on here now is that intelligence engine. And it's not just Pivot 3. Over the years, talking to customers and hearing them talk about the need to simplify management. On the slide here, you see some quotes from Gartner from 3 different reports that they published over the last year, that speaks to the need to have more intelligence, in hyperconverged to take and help organizations, simplify management complexity, particularly when you're trying to deploy multiple mixed application workloads on the hyperconverged infrastructure and take and manage different solutions that you may have deployed across edge to core to cloud. So let's take and talk a little bit about what we refer to as the Pivot 3 intelligence engine. So this intelligence engine has capabilities built into it to help you manage performance, data protection, security. The monitoring and analytics refers to all sorts of predictive or all sorts of information that we collect on system performance and health, so that we can do predictive analytics on sensing when there may be failures or when things may be suboptimized, from a performance standpoint. And then I mentioned earlier, that our architecture is based upon a multi-tier architecture, that has different storage media types in it: hard drives, SSDs, RAM, NVMe, PCIe flash. And so this intelligence engine, knows how to take advantage of those multiple tiers of media types to ensure that your performance SLAs are met. And this intelligence engine is all based upon the concept of policy-based management, simplifying things for you. So all you have to do is take and pick from predefined performance or data protection or security policies, or in some cases, a library of performance policies that you define, and then you apply that to your volumes, data stores, or VMs, based upon the unique SLA needs of that application. And so essentially what you're telling the system is what the SLA profile or needs are of that particular application, and now the system knows what applications are more important than others. So if there are periods of resource contention, it will prioritize resources to what you deem to be the more mission-critical applications. And instead of kind of walking through the next couple of slides that show you how this works in a slide sort of format, I'm going to turn it over to Keith now, and Keith's going to do a short demonstration for you, to show you how this policy-based management paradigm works and how that's applied to performance and security in particular. So Keith, you want to take it away?
Absolutely. Thank you. All right. Can you see my screen?
Yes, we can.
Okay.
You want to blow up your console there a little bit if you can?
All righty. So in the product, as Mike has already said, we have the intelligence engine built into the product that will manage in near real time the consolidated workloads and be able to deliver. Product has 5 built-in policies. The first is mission critical, As you can see here on the screen, I have 16 volumes, and the target performance of that policy, mission critical, is 1 millisecond of latency and 125,000 IOPS with a gigabyte of throughput. And then the read ahead and read warming settings that are listed in this. Our other products in the surveillance realm have different settings that are optimized for customer workloads based on the kind of product and the workloads that you're deploying here. Second policy here is business critical, as is policy 3. It has 2 volumes that have a targeted latency of 3 milliseconds and IOPS at 75,000 with a half a gigabyte of throughput. Policy 3, of course, has you can see the screen. Policies 4 and 5 are non-critical, and there are 2 volumes at policy 5. And so as the system comes under more and more workload and the QoS engine automatically starts enforcing these metrics, it'll be the non-critical volumes down here that will be at managed at a latency of 40 milliseconds and 10,000 IOPS and policies.
And Keith, if I could just interject here too, Keith used the term, targets for that latency, IOPS, and throughput. Think of the IOPS and throughput as floors, and so the system's going to take and manage your resources under the covers to take and ensure that those volumes, data storage VMs, don't drop below that IOPS and throughput floor, and that latency is a not to exceed target. So in reality, what the application is experiencing, is like in that mission critical is less than a millisecond. But what we're saying is we're guaranteeing that what you've designated as mission critical applications, won't exceed that 1 millisecond latency target. So just a little bit of additional color on that.
Outstanding. Yeah. This is the managed performance that lets you, as the DevOps staff, you can put your mission critical workloads on here and know that the settings and the workloads that are running at the non-mission critical or other policies will be managed appropriately. For the DevOps staff, today we're going to show how simple it is in the product to just go and add a volume and set all of these performance policies. So you would give, this is the create volume wizard that the IT staff would use. They'd select a policy here, a protection policy, and they'd give it a size of 20, and policy 5 is easily set. You move forward in the second step, and our encryption, when enabled in the product, is automatically all volumes created after initial setup of the key control server will enable encryption by default. It will generate new keys every time you go out there. Of course, if you also want to create a data store and mount that in the details, you can give that a name. And then, of course, move forward and confirm this. So this volume that I would create here, this is a long-running operation, so I actually won't complete this. It's a volume name on this particular storage pool. We call those a VPG. It would be at policy 5, and we've enabled the protection policies, the daily snapshots with encryption, and the information about the key controller and the volume name. And
So Keith, gosh, when looking at this, in like 3 clicks, you've assigned a performance policy to that volume that set a IOPS and a throughput floor and a not to exceed latency target that now the system, automatically under the covers is going to manage. You've also assigned a data protection policy that specifies snapshot frequency, retention policies, all those things, and then you've also elected to do data at rest encryption, on that volume. So all in 3 simple clicks, and now, you've told the system, how you want that volume, managed going forward, and so it's really that simple. 3 clicks. That's pretty neat.
Yep. And more importantly, the staff can't miss, or they might select something wrong, but you can't skip something and not encrypt something. You can proactively go in and not encrypt something, but there's a warning and a pop-up in the system. So Keith,
maybe show us.
It's very, very simple.
Yep. Maybe show us one other thing, because I know we get the question a lot of, well, can I change those policies, in real time? Maybe I assigned it performance policy 5 to start with, but gosh, in looking at the performance metrics and such, somebody's determined that, boy, I really need to move that up from a performance target standpoint. How easy is it to do that, and how does the system respond when you take and make a performance policy change?
Great setup. So it's a simple real-time operation for all of your production Tier 1 data. I've selected this iSCSI1 volume down here. You click on the volume you want to change, bring up the Modify wizard. You simply change the policy in real time. It's a click. Or this can also be a scheduled event. We have a industry-leading scheduling capability in the system. So if you want this change to happen regularly, you would set up an automated schedule, and that could change policies around performance over protection as you go. So you would click this change from policy 1 to policy 3, simply click the next button. That drives you, and you don't want to happen to make a change on this screen, so you confirm that and then move forward. And it's that simple. We believe all these features can be used for your production Tier 1 data, and all the features in the system. That's how fast it's taken to change that volume performance from policy 1 to policy 3. I think I got to here, Mike.
Okay. Well, good. I know we're running short on time. Keith actually has a demonstration of something else set up, but I think we don't have time for it. In that Keith, can show you that the effects of that policy change from how the data path is managed in the system basically happens real time. So it isn't that you have to wait, hours or a half a day or something for the system now to start treating the data associated with that volume differently from the standpoint of what resources it uses. That change takes effect in pretty much real time. And then there's also the ability to take and schedule those policy changes. So if you know that at Friday at 6 p.m., some particular application reporting is going to kick in, and you want to provide more performance resources in a guaranteed fashion to the volumes associated with those applications, you can schedule a policy change to go into effect at a certain time and then change it back at a later point in time. So there's a lot of powerful capabilities in this policy-based management engine that really simplifies ensuring that the right workloads deliver the right performance, data protection, and security. So I'm going to take and skip through these slides because Keith essentially demonstrated that. And what I'll sort of touch on here briefly is this flexible scalability capability. And so if you can take and optimize your hyperconverged configuration, based upon the exact amount of compute, storage, GPU resources you need, because we do have the ability to take and have nodes that are true hyperconverged nodes. You can run VMs on them, as well as they have storage in them to contribute to the overall pool. You can add storage-only nodes, and then you can add GPU-enabled nodes so that you can scale the solution based upon the exact amount of compute, storage, and GPU your application environment needs. Then we've talked a bit about technology, but what we're trying to take and deliver you as IT professionals is lower your total cost of ownership by the amount of performance that we can provide, allowing you to take and have higher application density, whether those are database VMs, Splunk VMs, or let's say virtual desktops. We've got a lot of performance comparisons that show that we can drive much higher application density per node on our system, and so buy less hardware, buy less software licenses to get the job done. What Keith showed you in terms of this intelligence engines, geared to take and ensure that you can deliver more predictable performance, for your applications based upon their individual SLA requirements, and in particular, make sure your most mission critical ones are guaranteed access to resources. That simple policy-based management approach that we deliver, allows you to take and lower your operating expenses, and then ensuring that you're delivering those mission critical apps, in particular, the right performance levels, is going to result in just more satisfied customers and more productive end users within your organization. So those are the business outcomes all this great technology is intended to take and drive for you. And from a solution standpoint, our customers are deploying hyperconverged infrastructure across these type of application environments. And then I'll just close with reinforcing the fact that we do indeed have solutions that are optimized for video surveillance and security use cases, and that's been a hallmark of Pivot 3 for a long time now. And with that, we'll close. I know we've run a few minutes over here. I apologize for that, David. Do we have any questions that we can quickly take?
Let's see. I don't think there's any questions in the queue right now, it looks like. I think you covered everything. Really great presentation, Mike and Keith. If people wanted to get started, let me just ask this. If they wanted to get started with Pivot 3, what's the first step that they typically take, or what do you recommend?
Well, what I recommend is sitting down with one of our solution architects or one of our authorized resellers and just talking about what your specific needs are. What's your current environment look like? What are the sort of applications you've got? What's your storage growth? All those sorts of things. And then we can take and, propose, a particular solution for you, based upon, your particular needs. And that may include, kind of walking you through a more detailed demo and just kind of describing, some of what I just briefly touched on today, in a lot more detail so you understand what we do.
Okay. Excellent. Well, I think that's all we have for now. I really appreciate the presentation and the live demo from Keith. That was really helpful to see the product in action. Thanks, Mike. Thanks, Keith.
Thank you. Thanks, David.
For more information on Pivot 3, visit their website, pivot3.com. I want to call your attention to the poll that's on the screen right now. It says, would you like to be one of the first to learn more about the Pivot 3 solution? Make sure you check out that question and answer that. I appreciate it. And I'll just leave that up while I announce our next prize winner. We've got an Amazon $500 gift card going out to Cliff Martinelli from Massachusetts. Congratulations, Cliff Martinelli from Massachusetts. We've got 3 more Amazon $500 gift cards to give away today, so make sure you stay tuned for those. And with that, it's my pleasure to introduce the next presenter on today's EcoCast. That is Mr. Dave Montgomery, Director of Storage Platform Marketing at Western Digital. Dave, are you with us?
I am. Thank you very much.
Take it away, Dave.
All right. Thank you. Let me try and advance my slide. Here we go. Here we go. Okay. I'm here briefly and tell you in a few minutes about composable infrastructure and where not just Western Digital is going, but where essentially all of our IT organizations will go. A little bit of motherhood and apple pie. Most everyone has heard of Western Digital. What you may not be aware of is We sell everything from silicon all the way to turnkey object storage and archive systems. We make NAND. We supply NAND to 5 out of the 6 of the world's cell phone leaders. The only one we don't sell to, for obvious reasons, is Samsung. On the memory stick side, I came from legacy SanDisk. We sell 1 to 2 million memory sticks and cards a day, 7 days a week. And on the disk drive side, just to give you an idea of the scope of the business, we sell about 350,000 disk drives a day, 7 days a week. So that part of Western Digital is extremely large. There's a business unit inside there where I'm from, Data Center Systems, which actually also makes storage platforms, servers, and as you'll hear in the next few minutes, some new technology that's helping reduce a lot of the cracks in the current IT infrastructure foundation. I'm going to talk for a few minutes about OpenFlex, which is a composable infrastructure product line that was introduced. But before I launch into that, I want to talk a little bit about the business problems it's supposed to address. Anyone who spent more than 2 or 3 weeks in IT or an IT data center or IT operations gets it that in order to go faster, you just have to throw more CapEx and operating expense at your IT infrastructure. You need to continue to roll out new hardware, faster hardware, bigger hardware. And then one of the corollaries here is everyone is understaffed. There's a chronic shortage of people to get the needs met in essentially any IT organization. Okay. In order to deliver that speed, no surprise here, you get lots of silos, you get lots of over-provisioning to make sure during peak demand times you can meet your service level agreements to your various internal customers. So this is a situation that anyone who spent any time at all in IT is probably painfully familiar with. And to get a little more specific, IDC did a broad survey last summer of actual, these were data center managers of $100 million a year and larger corporations, and they came back with some interesting findings, not really surprising. They think their staffs are typically only working at about 55% efficiency, mostly due to manual processes that could be automated, lack of sort of structure and consistent processes. So the staff they have could be much more efficient, but because of the way the legacy environments have shaped up, it just doesn't support it. Similarly, if you think about the over-provisioning and what's needed to deliver on business requirements, there's a lot of unused technology out there. That 50% of the technology that's already provisioned, not being used as backup or hot spares, that's only being used 50% because, again, they have to meet their business requirements. And the ironic part of the survey was that despite all of that, these data center managers, only 40% of them actually believe they could meet the service level agreements that they'd already committed to for their organizations they supported. So despite throwing lots of CapEx and OpEx at it, internally they believe they in 60% of the cases, they couldn't deliver what they were saying they could deliver. So let me give a couple of examples to show how this problem is going to get a lot worse before it gets better. The first one would be, all of us have heard about connected cars. And not just autonomous vehicles, but today when you're using Waze or Google Maps or your nav system in your car, it's a vehicle to infrastructure kind of communication. So when you look at a modern car, and particularly an autonomous car, but not necessarily, the amount of software and connectivity in that car is just skyrocketing. They expect in a few more years to have over 300 million connected cars on the road. And what a connected car really is a compute node, right? It's a mobile compute node. It joins a network, and then it leaves a network, depending on where it is and whether the car is operating or shut down, et cetera. So from an infrastructure point of view, that's challenging. That will require a level of flexibility that's really hard to achieve without throwing a tremendous amount of money at it. Likewise, your average car today has a couple dozen processors in it. High-end cars have even more in terms of the code needed to run that car. Now, anybody, my background is many, many years in enterprise software and servers and storage. And so from a configuration and change management point of view, this is a nightmare waiting to happen. Particularly when you think about it, right? Your high-tech car today is very software loaded, and it will allow you to personalize your dashboard, your instruments, et cetera. So not only do you have change management and config management, but you're allowing for a personalization of it. So from a software management point of view, this is a huge challenge. It's a huge challenge for static infrastructure, and yet alone, a mobile infrastructure. And then finally, something nobody really likes to think about too much, but that's security. Okay, most of us have read stories or test cases, whether it's on 60 Minutes or other news forums, that show people hacking in the cars, and they're disabling them or causing the windshield wipers to go when they're not supposed to, and things like that. But an important dimension of this is your car actually contains lots of biometric information and behavioral information. Your car tracks where you go. It may even track what you buy. And so there is a privacy and a regulatory dimension of this that will emerge that will add another huge burden onto someone's IT infrastructure. So just think about for a moment today, there's really no infrastructure except a dedicated one that could handle this, and it would be incredibly expensive and difficult to maintain. Another one we hear about all the time is surveillance, and then as a follow-on, facial recognition as part of that process. This was not my phrase. I think some industry analysts coined that surveillance is now where big data is going to meet fast data. And let's take an example of a relatively small building, 96 cameras. These are 1080 cameras, not 4K, not 8K, but 1080, which is considered to be sort of the minimum amount of resolution to run facial recognition software on. So that needs about a gigabit per second ingest from all your cameras. So what happens when you finally have some data and you're told you need to run facial recognition on it to find an image? Well, you take your captured image, you align it, you first find the eye locations and you convert it to a grayscale. You crop it out to get the background out, et cetera. And then you map it to your template and you see how many hits you get and does it meet the threshold to be a recognizable face that you've got in your database. And the interesting thing here is that today, and they've done these studies, a human eye can recognize about 97.5% of the time, can accurately do facial recognition. And facial recognition is defined as regardless of lighting or angle or clothing or background, you can recognize the person in the picture. The current state-of-the-art technology, as done by Facebook, documented publicly by Facebook, it can recognize the facial recognition at 97.2%, so at less than 0.5% worse than a human being. So this is very real, and it's coming. And the frightening part of it now is the trends are for much higher image resolution, many more cameras, and longer archival periods. So what that will do, it's obvious what that would do to your IT infrastructure. Yeah, your storage and your compute nodes would just have to skyrocket because, 99.9% of video surveillance data is never looked at. But the 0.1% that is needed almost immediately for usually some significant issue, whether it's security or things like that, or law enforcement. So that's another kind of challenge infrastructure has today. And finally, the third one is more of one we can all relate to, and that's online shopping. Most all of us do this periodically. Some do it almost exclusively. And one of the problems in online shopping is abandoned shopping carts. Lots of us, and I can speak personally, are always astonished at shipping costs. When you're buying an item that might be relatively inexpensive, and the shipping costs are essentially as much or sometimes more than the item you've got in your cart. depending on the actual venue, or depending on the actual company and the time of year, if it's a holiday, et cetera, this rate can get as high as 90% during some peak times. So what do you want to try and do here is, obviously, you want to reduce the abandon rate. Probably many, many ways to do this. One would be to give each shopper their own application container. So what happens when someone logs in to a site that they've shopped at before, immediately their purchase history gets pulled up. And then you look at their own personal rate of abandoning shopping carts. And if it's low, you're fine. You can just proceed as is. If you see they've got a relatively high abandon rate, you can then look at the contents of their cart. You calculate the profit margin in their cart, and then you map that against the zip code of the address they want to ship it to and estimate the shipping costs. And then you can decide what the threshold is to either offer them discounted shipping or free shipping. And as such, then reduce that abandon rate significantly. Now, this all sounds great, and if you're an IT person, it sounds interesting. But what it really means is you're going to have to stand up and tear down thousands of containers an hour. Again, you have no prediction as to what the demand might be, but every time somebody logs in, you need to do this. And obviously the goal is to improve your revenue, et cetera, but this is an infrastructure problem that would be extremely difficult to do smoothly in today's IT architectures. So this is kind of motherhood and apple pie, but anybody, as I said, who's worked in IT understands up until fairly recently, your data was used by a single application. It was pretty straightforward. The storage was dedicated, and the server or servers that used it had free access and no real issues. As I've tried to point out in the last couple minutes, what's happening now is you get lots of data from different sources. It's pooled and used among several different applications or many different applications. So it's very difficult to structure your IT to do this efficiently without breaking the bank cost-wise. So where do data centers have to go? I think it's pretty obvious that they still have to support your business, right? Which is the function of IT, is to support the lines of business that depend on it. In some cases, if you're a service provider, that is your line of business. And they got to mitigate the risk. They got to reduce the risk to the ongoing business. Okay, and they got to evolve. As I said at the very start of this, none of us can keep throwing CapEx and OpEx at IT forever. And in fact, IT always is asked to do less with more. It's one of many factors driving lots of work into the cloud. But essentially, the other dimension here is we've got to figure out how to make it more flexible and more agile. So when new business requirements come up, it doesn't mean wheeling in more racks of servers and more racks of storage. Okay. A key part of this, and this gets back to the efficiency part also, is you need better orchestration. You need a unified set of tools so you can provision storage on the fly of different performance levels. You can stand up and disaggregate virtual machines or processing, increasing the automation of lots of processes that are very labor intensive today. So that's where it has to go in order to reduce the spend rate but still meet the business needs. So this is really kind of a no-brainer slide, and we've heard all these terms beaten to death. But essentially, it's got to scale, right? Because our data volumes are going up nonstop. Okay, we've got to get more out of our IT purchases because of the inefficiencies. We can't just keep adding more partially used storage, partially used servers. And then the performance is we can't buy for peak loads and have them sit idle. It's linked to efficiency, but you need to meet the performance requirements of your lines of business, but you have to do it in a way that's not that's within budget. And the agility part is what I've already spoken to. You can't architect for peak demand in every function because you simply just don't have enough money and people to do that. So the term composable is being bandied about by lots of companies and standards organizations. And if you think of it as a kind of an evolution, you have turnkey systems, and there's a huge business in these, and there will always be a huge business, right? The picture I've got up there is a NetApp FlexPod, NetApp Cisco FlexPod, and these are all pre-configured for a specific workload. The most common ones you always run into are point-of-sale systems, and ironically, your point-of-sale system can be anything from an iPad with software on it for Square, or a large system with multiple servers, et cetera, for a large retail operation. But they're turnkey, and if you have not much IT staff, or you don't want to have much IT staff, they're a very good way to go to meet your business needs. The next one is we hear a tremendous amount about hyperconverged appliances, hyperconverged infrastructure. These are modular compute, storage, and networking nodes or boxes, kind of one size fits all, and you can pay as you grow. You can add these as your workloads increase. You can with virtual machines, you can migrate virtual machines around them. You can migrate data around them. They're basically software-defined abstractions of all your resources, and these are, excuse me, very cost-effective and very good if your range of workloads is fairly narrow, and you have a good understanding of what your workloads require, what your set of workloads required, and IOPS and networking throughput and data set sizes and things like that. That's what hyperconverged appliances are outstanding for. Where they begin to break down is when you begin to add more and more workloads that hit the boundaries of these appliances. Then you keep deploying them to meet your business needs, but then you ultimately result in some of these appliances are grossly underutilized in processing because you need the storage, and conversely, they're grossly oversubscribed in CPU, and the storage is sitting idle. So what happens is when your workloads start to diverge, the inefficiencies in these really begin to show up. And so what happens is you end up with some of the same similar problems. You're over-provisioned, you're spending too much money, the typical problems that we face every day. So moving along to sort of the next stage of this is what we're calling composable infrastructure. And what this really means is your hardware and your storage and your networking resources are all dynamic, they're all virtualized, and you can pull together whatever you need in terms of compute, storage, and networking bandwidth on the fly to meet the demands at that moment, and then you can reallocate those to other workloads that require them. So you're not you're not provisioned for peak loads, but yet you can meet all your peak loads. So it's a pool of resources. You can compose it and you can make it available on demand. And what this lets you do is then get a much better, essentially, asset utilization. It's an old concept that you learned years ago, but basically you get a lot more out of your storage and compute and networking hardware if you're able to do this. So just a little bit of level setting for definitions, right? Composable infrastructure is disaggregated hardware, right? And as I said at the previous slide, you can pool it, you can pull it together, you can disaggregate it. How you do that is with hardware that's designed very granularly to allow that, and orchestration software, right? And key to an orchestration software is one or usually multiple APIs they use for control of this kind of equipment. And the why is straightforward, right? More agility, better asset utilization, more consistency in meeting service level agreements. Okay, Western Digital's vision here is it's limited to storage in the hardware side, but we're supporting very much a disaggregated open infrastructure. We have opened up our hardware design to anybody who wants to make it. We have an API I'll talk about in a minute, which we're already submitting to standards bodies. The scalable part means that whether it's CPU or networking or storage, you can scale within a rack, you can scale across multiple racks. And then the disaggregated part, as I said a minute ago, it lets you pick and choose how much you need of any one element to meet what you need. And then the extensible part is kind of interesting. Today, we can do storage in the future, and we're working with companies and other companies independent of Western Digital are working on this. They will allow compute, DRAM, GPUs, other memory to be also allocated on demand. And so, the box on the left we're all familiar with. It's a rackable server. This one's got 2 Intel sockets, a bunch of SSDs, and the usual networking hardware out the back. And inside this, you've got a GPU also. You might have a floating point array, field programmable, FPGA, and the usual stuff that's under the hood of a server. Logically, it's exactly the same. With a composable infrastructure, you can take all these bits and pieces and you have an abstracted server, but essentially it's the same concept. Is you just logically you don't really know or truthfully care where these resources are coming from. Now, on the storage side, NVMe over Fabric is emerging as a very powerful technology to share devices, to share compute storage elements over a common fabric. It's a building block approach where you have an NVMe attached flash, NVMe attached disk, NVMe attached compute or server. And what it lets you do is you can compose, as I said multiple times, compose the elements that you need and match your performance to whatever media you want or however many processors or cores you need. Now, last August, Western Digital announced a technology program with the very first NVMe over Fabric attached flash and disk devices. So what this enables is one wire, the same protocol, to access hard disk storage and flash storage. And again, the only differentiator here is your application needs to understand what the storage performance is at the end of the wire. And so if it does not need flash or needs a small amount of flash, it simply partitions out, grabs one or all of the fabric devices that are flash attached, or the flash fabric attached devices. And then if it needs a lot of bulk storage, less performant, the disk technology is what you'd use. So we have done studies here, and they're available on request that show that compared to hyperconverged infrastructure, you can reduce your total cost of ownership by up to 40% because you can compose the storage on the fly. Now, the API is, I won't speak at length to it, but that's the other half of the coin. If you remember a couple slides back, I said disaggregation is the hardware. The hardware is designed to be disaggregated. The composability is driven by orchestration software that uses APIs. And so what the API, and Western Digital has already submitted this many months ago to various standards bodies, and we have an enormous ecosystem of partners that are currently working to support it with their products, hardware and software. It lets you abstract the resources to virtualize them and use them and then free them up for the next. It will become equally as important as any hardware. And this is a complementary kind of API to work with the Redfish and Swordfish APIs that are already in widespread use today. This is one for hardware resources and storage resources. Why us? I mean, the question is, okay, why is Western Digital bothering to do this? Well, the reason is you saw in my very, very early slide, and that is Western Digital is remaining a storage vendor, right? Our scope is such that we quite literally store over half of the world's data, and we want to continue to provide storage in every area we can, all the way from the edge of a device to a data center. We've got an enormous patent portfolio in the storage space, probably the largest storage patent portfolio in the world. And this is a logical evolution of where the company wants to go. So let me just wrap it up. In summary, what OpenFlex does and what a composable infrastructure will do is it disaggregates the various elements that I walk folks through. The only reason you care about it, let's be honest, is you want to save money. You want to save money and headcount to do this. And that's why eventually we will all go towards this architecture. And then apologies for the graphic. I couldn't find anything that was big and fast except this. As I said, all of our data sets are getting bigger, and the requirements to process them are all getting faster. So even though we think about big data needing not much storage performance and not much compute, and fast data being nice and small but needing lots of compute, as I said, your big data sets are requiring much more speed in processing, and your real-time data sets are actually getting larger. So it's a bad convergence in terms of hardware. And that pretty much wraps it up. I will turn it back over to our moderator for Q&A, and I welcome your questions.
Yeah, great presentation, Dave. Let's do some Q&A here, and while we do, I'm going to pop up this poll question on the screen. Let me call the audience's attention to that. Would you like to be one of the first to learn more about the Western Digital solution? Check it out. Make sure you answer that poll. So the first question came in. They're asking if OpenFlex Storage offers data compression.
OpenFlex Storage supports data compression. Remember, at the end of the wire, they think it's just a storage device. So if you want to employ data compression algorithms, absolutely, you do that. To be blunt about it, Western Digital will always be just a storage arms merchant. And so whatever form of data compression or RAID or encryption you use today can be used on this.
Okay. And what's the availability of the OpenFlex solution? Is it available now?
It is available now in limited volumes. We have relatively small, globally, a set of early adopter partners that are working on it. It is going to hit volume shipments in about 2 more months, about April of this year, and at which point in time we'll have a very active partner program for evaluation and trials and things like that.
Okay. And if somebody wanted to be part of the ecosystem, is there some way to join?
Absolutely. That's actually quite easy. westerndigital.com, and you can either search on that for OpenFlex or composable infrastructure, but just go to the corporate level website, westerndigital.com, and there's a link on products, and then you can look at storage platforms and surf around. But yeah, it's quite easy to sign up. Okay.
Well, very nice. You just got some good feedback came in from Bruce. He said this is one of the most useful presentations for him today. So
thank you.
Great. Yeah, great feedback. I think that's all the time we have for live questions, but thanks so much for being on the event today.
Yeah, thank you all for attending. I appreciate the time.
All right, for more information on Western Digital and the OpenFlex solution, make sure you download the handout. It's a technology brief on the future of data infrastructure. And with that, it's time to award our next Amazon gift card. That Amazon gift card is going out to Paul Willett from Colorado. Congratulations to Paul from Colorado. And now it's my pleasure to introduce our next presenters on today's event. That is David Huskinson from Pure Storage, part of the Rapid Restore Solutions team, or the manager of the Rapid Restore Solutions team, and Roy Child, who is a product manager at Commvault. David and Roy, are you here?
Yep, we're all ready to go.
Awesome. Thanks for being on. Take it away.
Okay. Thanks very much, and we appreciate the time we've got today. So I'm David Huskinson. I'm the Rapid Restore Solutions Manager for our FlashBlade and our Object Engine technologies, and I'm co-presenting here with Roy Child from Commvault, who's the product manager for IntelliSnap integration and was very involved in the integration efforts that we built together. Roy's going to kick it off, so I'm going to hand over to Roy while I get my slides fixed up here.
I think we may be seeing the same thing. So if it's all right, we can work through this. Just ask to advance the slides.
Yeah, that works great.
So the first slide is showing the overall architecture of our joint solution. We have components from both companies. We have the Pure Flash Array, which is the production block storage, all flash. Everybody should know and love that. We have Commvault complete backup and recovery in the middle, using our IntelliSnap snapshot orchestration component that bridges between the hardware snapshots on the flash array and our data protection software. And then we have the FlashBlade, which is the repository for the protected data that's coming off of the flash array. And it can also be a source for data protection as well. But the component we're going to cover today is the marriage between all of these components and the interactions and the benefits of tying all these things together. So if you can go to slide 2, please. So the first thing we're going to talk about is the production side of it, which is the flash array and IntelliSnap managing the hardware snapshots and using those for protection, recovery, and disaster recovery. So go to slide 3, please. So what IntelliSnap technology is, it's essentially an orchestration layer that ties together applications and storage hardware with policies and schedules and automation. So in Commvault terms, that means that we're going to put an agent somewhere that knows how to talk to a particular data type, whether that's a database or a set of virtual machines or some raw files, and use the hardware snapshots of the underlying storage to protect that without having to worry about things like what's my volume layout, managing retention, creating snapshots independently, no scripting involved, and things like that. So it's a very simple way to get a lot of benefits around your faster data protection and recovery, ability to replicate off-site using hardware replication capabilities, and then perform granular recovery for things like point-in-time database restores and recovery of virtual machines with very short recovery times. Go to the next slide, please. And so one of the solutions that we've got between Commvault and Pure, and this is with Cisco as well, is the FlashStack. And FlashStack is a converged infrastructure solution where you have Cisco Compute and the Pure flash array, in a single solution with predefined configurations validated by both companies and deployed for optimized for workloads. So as you can see, we've got a very broad set of supported applications and data types that can live on this FlashStack, and you get the simple single purchase and a simple deployment model versus building out a traditional server plus storage architecture. And the FlashStack, and you can go to the next slide. When we add Commvault in there, you get the benefits of IntelliSnap that I just talked about. You get plus the hardware benefits of the density, the reduction in complexity through the simplified networking of Cisco, and overall reduction in costs because you have less space, less cooling, less power requirement, and then the resiliency that both Cisco and Pure build in. And then, as I mentioned with Commvault, in addition to IntelliSnap, you get all of the benefits of Commvault, including the indexing power and the ability to tie into our virtual repository, so that whether the data is in FlashStack or sitting on FlashBlade or in the cloud, it's all one management point and one management layer for operating data protection and recovery across the entire environment. So go to the next slide. So we have a Cisco validated design for virtual server infrastructure, and this is generic virtual server infrastructure, not tied to a specific workload as we had on a couple slides ago, but managing VMware 6.0 and Cisco UCS, and the benefit of the validated design is that Cisco and Commvault and Pure all work together to build out a very prescriptive configuration and document that configuration so that a customer can easily stand it up, follow the process that's in the document, and be assured that there's a guaranteed success outcome. The use cases that we've identified here, single site protection plus multi-site protection, both using IntelliSnap for the snapshot management plus backup and disaster recovery within the Cisco framework. That can then again be expanded to the virtual repository and the Commvault site can be expanded to include things like FlashBlade and cloud as your needs grow. You go to slide 7. Just illustrates a few of the other joint collateral that we've got that you can go and download from our various sites. We've got a few pieces on the Cisco side and then some Commvault and Pure co-branded documents as well about various use cases around Oracle, VMware, SQL. So if anybody has trouble finding these things, we can help you get to them. But a lot of published materials about the joint solution that you can go out and refer to. So you can go to slide 8, please. So I just want to cover one joint deployment that we've got with the FlashStack, where we had a healthcare leader, and they needed they needed a more modernized solution against to replace their EMC solution, and the FlashStack gave them that single platform with IntelliSnap giving them the RPO and the RTO that they needed to hit to serve their base of 180,000 physicians, and we did a very simple POC between the three three companies, and we're able to show the value very quickly. And this has actually been a growing customer for all of us since then. So we're of course very happy to discuss with you what we can do to show you the same kinds of results. So we go to slide 9. I'm going to turn it over to David, and David will talk about the right side of the picture, where we have Commvault and the FlashBlade talking to each other for the protection side of things.
Perfect.
David?
Thanks, Roy. I think we got the slide sorted out now, so I think we're good. So Roy's done a great job of explaining the sort of left-hand side of that slide around the integration we have between Commvault and FlashArray. But the story doesn't stop there. So you can see on the slide, on the to the right-hand side, we have our FlashBlade offering. So FlashBlade, let me set some context here. FlashBlade is not a purpose-built backup appliance. FlashBlade is an all-flash storage platform, and because it's all flash, we get fantastic performance for deduplicated backups. But FlashBlade is much bigger than that, and I'll come to that in a moment. But certainly what we see with Commvault and FlashBlade is we see some fantastic recovery speed, just because we don't, with FlashBlade, because it's not legacy spinning disks, and those of you who know deduplication breaks down your backup into a series of blocks, and if you're recovering from a PBBA, then you pay a restore penalty as you locate the blocks to reassemble them to recover them. And we just with an all flash offering based on an object store operating system, if you like, we kind of get over that problem. So really let me see if I can get to the next slide. Okay, can you move me to the next slide, please? Thank you.
Yes.
So really, our approach here, certainly in our very strong partnership with Commvault, is to really present a sort of a much more modern approach to data protection, and that's what FlashBlade delivers. It's part of our flash to cloud strategy that we'll be talking about more over the next few weeks. And so you can see here, this slide really just talks about the restore experience. And again, we've been we've been selling FlashBlade with what we call our rapid restore use case for some time. And customers, we speak to customers about, recovering large databases, recovering large applications, and it just becomes, impractical. Deduplication is a great technology for optimizing the backup, your actual backup time, and also to optimize storage space, but it's not really optimized for recovery. So, there's a whole thing in the backup world. I do more backup than recovery, so I tend to want to optimize for backup. But actually, with the pure FlashBlade, you actually get the best of both worlds. You get the level of optimization that Commvault can do with its deduplication layer, and then you get the recovery performance that we can give you with FlashBlade. Next slide, please. So briefly, what is FlashBlade? So as I said earlier, you have to shift your thinking a little bit here. This is not a purpose-built backup appliance. This is a highly scale-out storage platform. And it's easily upgradable. You can have up to 75 blades. That's about 3 petabytes of backend storage. You can add blades. You can add blades to the infrastructure online. You don't have to take anything down. It's much like our FlashArray technology in that it's non-disruptive. We have this concept of evergreen, which means as you invest in FlashBlade and as Flash technology changes, Pure will come back and upgrade your box as part of your ongoing support agreement with us. And it's a completely scale out device. And as I say, it gets up to 3 petabytes. And performance is absolutely phenomenal. Next slide, please. So as I've said a couple of times, I think I'm sort of repeating it because it's really important. This slide sort of shows you the level of complexity that you get in data centers. And typically, as you add more applications, as you add backup products, I think all of you will be familiar with this, with the idea that you're creating more and more silos to manage, and it gets more complicated. And really what FlashBlade is intended to do is to provide that optimized layer of storage for backup and recovery, but for a bunch of other use cases. Could you move to the next slide, please? And the next one. Thank you. So really, we sort of call FlashBlade our data hub. So yes, backup and restore is a fantastic use case for FlashBlade, but also you can see from the slide here, we support many other capabilities like, analytics and Splunk and Elasticsearch and Spark. So we really see this as a highly optimized platform that actually doesn't, is not fixed on one use case. It's fixed on a bunch of use cases, of which backup and restore is really just one of them. So I'm going to hand over back now to Roy, who's going to take the next slide.
Thanks, David. So give kind of an idea of the things that Rapid Restore and FlashBlade can enable here with Commvault. So we can do temporary copies of things. So for example, temporary virtual machines. You need a copy of a VM for a test dev case or to do a DR test. Being able to run that copy directly off of the FlashBlade and then tear it down again based on your needs. Live VM recovery. So similar concept. You need to restore a virtual machine, and you need your RTO, to be as close to 0 as possible. We can run that from the FlashBlade and then have it move to the production storage you want it to live on, and the VM's accessible and running at a higher performance level during that process than if you were running it from a slower spinning disk backend. And then being able to run granular recovery. So we call it live file recovery. That's basically you want to pull an object out of a virtual machine. So be able to run that from the FlashBlade and pull it straight out, so you get a faster recovery experience out of that. And then it goes beyond that as well to traditional recovery, but the Flash really enables the faster live or more live options. So next slide, please. And then similar to what I talked about with the test of VM machine copies, we can take database copies and run those off FlashBlade as well. So you need to spin up a couple of copies for your testers, or you have a reporting database that needs a periodic refresh. We can, rather than creating a separate physical copy, we can spin that up straight out of the data that we've written to FlashBlade, and save you on your storage infrastructure costs. So the pieces of the puzzle here, of course, we have the Convolve Orchestrate is the engine that's putting all of the steps together, and then the FlashBlade, being the fast platform that it is, makes those copies perform better than if they're coming off of a spinning disk platform. Next slide. So then, just to give an illustration of how easy that can be, our interfaces, our Convolve Command Center web interface, is essentially 4 simple steps to create a database clone. This is an Oracle database, but the process is similar for other databases as well. And you're just picking a few options of where you want to live, and a lot of these options are optional. And apologize, it's a build out, I think. So if you can build that out all the way, please. So then the simple options and the reservation period mean that you don't have to touch this again. Once it's up, it's up. And if somebody wants to come in and extend a reservation, they can do that. But if nobody comes in and takes any other action, at the end of the reservation period, the copy goes away and you're left with the state that you started in. This can also be scheduled. So if you have a database that needs a periodic refresh, like I mentioned reporting earlier, it's very easy to put that together and get the copy you need, where you need it, when you need it, without sprawling storage footprint to manage that, or the IT time to make it all happen. Next slide, please. So example of where we've had some success with the rapid restore deployment. We have a SaaS platform that covers air travel carriers in Miami, and they are supporting both faster restore time for their SLAs that they were missing, and also a greater than a petabyte data lake on the FlashBlade together. So they've shrunk their storage footprint significantly by consolidating these workloads into the data hub. They've moved their archive from the cloud onto the FlashBlade so they can run analytics against that data. So they're more agile as a business because they can perform those analytics faster on FlashBlade than they can in the cloud. And they've also reduced their restore times dramatically. You can see it went from 2 days to 4 hours by moving to the FlashBlade, and they're over 2 petabytes non-disruptively on that same piece of hardware. So it's it's a pretty impressive story when you think about some of the challenges that you'd face in a more legacy architecture with getting to this same kind of a state. Next slide, please. Another one, we had a property management service in Ohio, and they're looking at a consolidation of unstructured use cases, also doing some AI and analytics. Right? So now they've got one platform that serves as their data storage for backup, and also as the source for their data analytics and AI data. Going from 40 hours to restore a 4 terabyte database, now down to minutes, is dramatic value for the company. It really helps with their resilience and recovery stories, and you're able to be a lot less. It reduces the risk for the company and potential for loss in the event of an outage. So next slide, please. I'm going to turn it over to David to explain what's coming soon.
Perfect. Thanks, Roy. So just in the interest of time, I just wanted to close out with 2 remaining slides here. So you can see here, so I want to be really clear about this. We're not selling futures, but we have a very big release in March 2019, as you can see there, We have this in the lab right now. So some of you may know that in August of 2018, we acquired a company called StorageUse. And StorageUse were really one of the market leaders with their cloud gateway product. And so we acquired that technology, and then from March 2019, we'll be offering. We've renamed the product that we called Object Engine, and we're really offering all the advantages of FlashBlade, as you've heard me and Roy talk about. But we're also layering on top of that our product what we've now called Object Engine. And in this initial release, it will be an appliance. But as we roll out over this year, we'll be selling it in different form factors. And really, if you could move to the next slide, please. What Object Engine really does is it's a highly performant, highly optimized deduplication engine. I guess the difference between it and others around is that it scales really well. When it was designed 4 or 5 years ago, it was designed specifically with the cloud in mind. So it has all the sort of features, if you like, of a cloud-based product. So it's stateless. It scales really easily, so it's very easy to add additional nodes as your data expands and you need to improve performance. You can add additional nodes to Object Engine. It offers a single namespace. So typically we see with most PBVAs today that deduplication works inside the boundary of the appliance. Object Engine really allows you to send multiple data streams to it from different locations and will produce that single global namespace. And it's very, very fast, and it works perfectly with a lot of our data protection vendors. We already have some joint Commvault customers that use the old version, which is StorageUse, and we're testing it right now with a bunch of Commvault users as well. So this is an exciting. This is Pure's really first acquisition, and we're bringing together FlashBlade and Object Engine. So we're extremely excited about this, and you'll start to see this come to market over the next few months. So I think we can conclude down. I think we're going to do some Q&A.
Yeah, great presentation. Thank you so much, Dave and Roy. We do have some questions here. So first one is, how is the data copy integrity maintained? Is it dependent on source data, or is there an additional layer of check?
There's obviously inside, from the FlashBlade. I assume we're talking about FlashBlade here. From the FlashBlade side, there's a bunch of integrity check-in. I mean, if you look at Purity, which is effectively our operating system, Purity was engineered from the ground up with Flash in mind. So we take advantages of all the capabilities of Flash around error checking and validation. It's quite a big subject, so feel free to come to us offline. But there's a lot of actual redundancy and error checking inside of the FlashBlade itself. Okay, nice. And let's see, does Commvault have an official CVD with FlashStack?
Yes, as we mentioned on the slide, there's one for virtual server infrastructure on VMware 6 update 2. Okay, and can you kind of summarize how does FlashBlade and Commvault work together to reduce recovery times?
So, Roy, if you like, I'll tell you this one. Commvault produces great deduplication rates on the front end, and if you were just sending that to a standard NFS share or a data domain, you'd have really terrible restore performance. But just because of I think there's really two things. I think there's really two things that drive that improvement at the back end. I think the first thing is we're in an all-flash universe right now, so you don't pay the physical. As I said in the presentation, you don't pay the physical cost for locating blocks and then rehydrating. And I think also running an object store style operating system or architecture inside of FlashBlade, that makes a massive difference again to the restore performance. So I'd like to say that both the features of Flash and the object store architecture we have really improved those recovery times.
Very nice. Very nice. Well, it looks like that's all the questions we have here in the live session, but a really great presentation. Sorry about the trouble with the slides, but the presentation was great. So thank you, Dave, and thank you, Roy, for being on the event today.
Pleasure. Thank you very much.
All right, for more information on the Pure and Commvault joint solution, make sure you check out the handout that's available for download right there in your audience console, because it's a product brief on modernizing with Pure Storage and Commvault, and it talks about the two solutions and how they work together. So I'm sure that would be of great interest and answer some of your questions. So make sure you download that handout. If you haven't answered the poll question on the screen now, it is the time to do it, because I'm advancing on, and I'm going to do a gift card giveaway right now. But before I do that, I'm going to pop up this poll question on the screen, and that is 12 months from now. If you remember, I asked this question at the start of the event for your current state of convergence, if you will. This question is 12 months from now, looking out a year, what do you think the percentage of your servers will be that are utilizing converged, hyperconverged, composable, or integrated platforms? So answer that question, and then just select one answer, please. And the next prize winner of our second to last Amazon $500 gift card is Michael Waring from Nebraska. Congratulations, Michael from Nebraska. I've got one more Amazon $500 gift card to give away after our next presentation, so make sure that you stay tuned for that. Now let me share the results of this poll with you. And it looks like interesting results here. So I'm going to go back after the event and compare these to the original poll that we asked to see how things have changed or how you expect things will change in the next 12 months. But that's the results of the poll. And now it's time to introduce our next presenter. That is Ankur Desai. He is the Director of Products at Robin Systems. Ankur, are you with us?
Yes.
Thanks for being on.
Thank you. Good afternoon, everyone. This is Ankur Desai from Robin Systems. Thank you for joining the presentation today. Today we are going to talk about how to deliver big data and databases as a service on Kubernetes using the Robin Hyperconverged Kubernetes platform. And we'll also see 3 demos on how to deploy, scale, snapshot, and clone applications using one-click simplicity of Robin. So if you look at hyperconverged infrastructure, there is one driving principle, and that is simplicity. The reason HCI is so popular is basically, we are simplifying the experience of deploying applications and managing applications for the end users. Now, this is very, it's a unique way of looking at things where you don't focus on the infrastructure, but rather you focus on the applications that need to be delivered on the infrastructure. So traditional HCI solutions, they have solved this problem using a hypervisor-based approach, where the hypervisor is the central to the solution. But as we move towards containers as the preferred medium of virtualization over virtual machines, and if you're interested in learning more about why containers over virtual machines, containers are lightweight, they spin up faster, they are more portable, they consume fewer resources, and then they are more performant than virtual machines. So there's this whole wave going on in application modernization where people are modernizing the applications using containers rather than virtual machines. So now when that happens, virtual machines are being replaced by containers, and then you have to think about whether hypervisor as the central unit of your hyperconverged infrastructure is the right thing to do. And that's the driving principle behind our platform, where Kubernetes becomes the central driving unit instead of an hypervisor. Right? So with Robin, using Kubernetes, You can deploy any big data database on any on-prem data center, on in public cloud using one-click operations. Similarly, you can manage lifecycle for entire applications and the data that belong to those applications. And you can avoid any infrastructure and cloud lock-in. You can make your applications really portable across cloud and on-prem data centers. Let's look at our architecture and the principles behind it. We are a Kubernetes-based, completely software-defined hyperconverged solution. We are not an appliance. We don't ship with hardware. You can run Robin on your on-prem data center in virtual machines or bare metal, or you can choose to run Robin on AWS or Azure or Google Cloud Platform. The central unit of our orchestration platform is Kubernetes, because we will be deploying all the applications as containers, not virtual machines, because of the aforementioned benefits of the portability and lightweighted nature of containers. But beyond just Kubernetes, we add our built-in enterprise-grade storage stack to the platform. So this storage stack will give you the ability to create snapshot clones, and it will guarantee quality of service for your applications. Next, we add a virtual networking layer to Kubernetes. So this is OVS and Calico-based flexible networking, and we provide overlaid networking and persistent IPs for Kubernetes-based deployments. And on top of these three components, we have our application workflow manager. And this is the brain behind the operations. When you click on, let's say, Hortonworks in our App Store, the application workflow manager does everything behind the scenes for you. So for you, it's an App Store experience where you just click on an app in an App Store, everything happens by magic, and the application workflow manager is the magic or the magician behind that magic. And we'll also take a look at 3 demos today where we actually look at how to deploy applications using Robin. So without further ado, the first use case, deploying any big data and database application on Kubernetes. So let's say a developer wants to deploy a big data cluster like Hortonworks. Without Robin, they'll have to create an IT ticket for provisioning hardware, install Kubernetes, find the right containers for each service within the Hortonworks stack, set up storage volumes, configure affinity, anti-affinity if they could, if their storage provides anti-affinity rules. So all of this might take weeks and months. With Robin, you simply go to the App Store and you click on Hortonworks. You provide a couple of inputs, and within 15 minutes, your Hortonworks cluster will be up and running. Now, let's take a look at an actual demo of the product. So here I'm going to the App Store, and I clicked on Hortonworks. Now I have to provide some simple inputs, like what would I like to call my application? Let's say HTTP1. And what are the services I want to turn on? Because Hortonworks is a complex stack, I want to turn on Hive and Kafka, but not all the services. You can also modify the number of resources given to each service and simply say provision application. So within a few minutes, typically within 15 minutes, your Hortonworks cluster would be up and running. And this is, all of this is possible because of our hyperconverged Kubernetes platform, where we take care of provisioning all the storage volumes, making sure all the containers are in place for the services you have turned on, and making sure all the data locality as well as affinity rules are in place when the Hortonworks cluster is finally up and running. And all of this happens within 15 minutes. The next use case is snapshotting and cloning entire application, including the data in it. So snapshots are useful when you want to recover from user errors or some data loss and you want to go back to a point in time. Whereas on the other hand, clones are useful for collaboration between, let's say, dev and QA teams. If you want to hand over the exact environment your dev team was using, including the data and including the cluster configuration to your QA team, if you want to replicate it, you can easily do that using a clone. Now, the key part here is the snapshots and clone Robin creates, they are not only for your data. We actually create a snapshot of the entire cluster. So if you want to go back in time where, your MongoDB cluster was 3 nodes, now you have 4 nodes, and you want to go back to the point in time to what the data was at that point in time. So if you do the snapshot with Robin, you will actually get the cluster configuration as well as the data snapshot. Right? So that's a unique way of looking at snapshot, and that's what we do at Robin with our platform. So now, without Robin, if you want to create snapshots and clone for the entire application, it's not an easy task to do. You have to ask the storage admin to provide, storage volumes and then take the snapshot. You have to, if you want to create clones, if you have to ask the storage admin to clone all the volumes across partitions or database, stand up new VMs. All of these things might take a week or two. With Robin, it's very simple. You go to the App Store, you look at what applications you have running, simply say snapshot or clone the application, and you're done within a few minutes. So let's look at an actual demo. So this is a Cassandra dev cluster that I want to snapshot so that I can restore it to a point in time. I simply go to the cluster, to the application, and say create a snapshot. I'm going to name my snapshot snap1 and just say create, and that's it. Within a couple of minutes, actually ready. And this is a redirect on write snapshot, so it's pointing to the storage. And then if you want to create a clone from this snapshot so that your dev environment is handed over to your QA team, you simply go to the snapshot and create a clone from the snapshot. Right, so I name the clone clone1, and I say clone. Now, within a couple of minutes, my clone will be ready and available to be handed over to the QA team. So this is a really simple way of actually managing your applications and improving the collaboration between different parts of your DevOps team. The next use case is scaling your application, right? And scaling stateful applications, especially the big data applications like an Elk Stack or Hortonworks or a Cloudera application. It's not easy because there are different components to the data distribution or the data platform. And scaling each component might have its own nuances. For example, scaling name node in Hortonworks is completely different from scaling out data nodes. Right, because it's different roles each component is playing, and they are very unique in terms of how they operate. So all of that simplicity is brought to you by Robin by taking care of all the steps that are required to actually scale different nodes in complex data stacks. Right. So with Robin, once again, instead of taking hours and weeks to go through each step and different, developers and IT admins, you can simply go to the Robin console and just using simple one-click operations, you can scale your cluster out or scale it up. So now let's take a look at actually scaling up a name node in your Hortonworks environment. So this is the HDP cluster I deployed a minute ago. And now let's say if I want to scale up the name node, I simply go to the name node containers, go to QoS, and I say I want to add more CPU. Right, so from 1 CPU core, I have gone to 2, and I have also added more RAM. When I say apply, within a minute, without interrupting the operations of your cluster or your application, your name node has now actually scaled up. So if there was sudden demand for your name node or sudden demand for distributing data across the data nodes, which put stress on the name node, now it's really easy to do with a simple slider to actually add more resources in real time. So once again, to wrap it up, Robin allows you to focus on applications, not infrastructure. And with Robin, you can deploy any big data database application on-prem or in the cloud with one-click operations. We are not an appliance. We are a software-defined hyperconvergence solution. So you can choose your own commodity hardware, or you can run Robin in AWS, on Azure, or in Google Cloud Platform. Beyond the day one activities like provisioning and deployment, Robin also makes it easy to manage lifecycle for your application. For example, creating snapshots, clones, backups, upgrades, scaling with simple, using simple sliders. All of that is out of the box, and it gives the end users a self-service experience, making them more productive, right? And you avoid any infrastructure and cloud lock-in, because with Kubernetes, you get the ultimate portability, right? All cloud providers, public cloud providers, support Kubernetes. Once you have your infrastructure built on Kubernetes, you have the portability of moving either among the cloud providers or simply running your own Kubernetes on-prem and managing it yourself. So Kubernetes gives you that ultimate portability across different infrastructure options. And with that, I will hand it over back to David.
Yeah, great presentation, Ankur. Really fascinating stuff that you all are doing at Robin. So I've got a few questions for you. While we do those questions, let me leave up the poll question on the screen for the audience out there. It says, would you like to be one of the first to learn more about the Robin Systems solution? I'll just leave that up. So first question here is the Robin solution an option for companies with more traditional applications like traditional on-premises databases? Could the Robin solution help with use cases like that? Or what are the primary use cases?
Absolutely, yeah. So we help with all data-heavy applications, and when I say applications, I basically mean in the container world, stateful applications are databases and big data systems. So we actually have support for running Oracle on Kubernetes, even including Oracle RAC. So you can go to Robin App Store, click on Oracle RAC, simply state how many nodes you want, and within a few minutes, your Oracle RAC would be up and running on Kubernetes. We also support SAP HANA, MySQL, SQL Server. So all the relational database applications, or rather relational database systems, are supported by Robin. At the same time, we also support modern NoSQL databases like Cassandra, the DataStax version of Cassandra, MongoDB. All of these, are available in our App Store, what we like to call App Store. You simply go in there, click on the application you want to deploy, and within a few minutes, your application would be up and running. And this is a completely self-service experience. Once you set up the Robin cluster, for your developers, for your QA teams, for your data scientists, if you're into big data applications, for your data scientists and data engineers, this is a completely self-service experience where they go to the App Store and deploy applications themselves.
Very nice. A question that just came in here, they're asking, could Robin help in a private cloud environment?
Absolutely, yeah. So like I mentioned, we are not bound to any hardware or any cloud option. You can choose to run Robin in your private cloud if you have a virtual machine environment with vSphere or VMware, we actually run on top of the virtual machines too. But at the same time, we give you the portability. Once you're up and running on Robin, you have the portability of moving your applications across all the important public clouds, right? So at this point, we support AWS, Azure, and GCP. We plan to support more in future. But Robin is completely hardware agnostic and cloud agnostic. And basically, that is a benefit that is extended to the Robin platform from Kubernetes. You can run Kubernetes in private clouds or in your traditional on-prem data centers or in all the major public clouds. And Robin extends that same benefit to our customers.
Okay. A question just came in from Bruce. Am I running my SAP front ends and middleware on Robin, or would I just run the database?
So you can do both. Robin is not only limited to the databases, although that is typically the number one use cases our customers start with. But we have customers, for example, we have a customer called Lawrence Livermore. They are running the entire Oracle EBS application on Robin. That includes the database that is running underneath, but they are also containerizing EBS itself and running it on Kubernetes using Robin. So database is, especially in the DevOps world, the database is the first thing people do because there aren't many options to actually bring the agility of DevOps to databases. Robin, gives you that. But once people start on that journey, they realize that once you can create containers and those containers can be run on Kubernetes, there is actually no limit to what you can modernize. You can modernize the databases using Kubernetes and Docker, or you can actually go ahead and get the application layer embedded into one app, what we like to call an app at Robin, where you go to the App Store and you see the App Store, a private app store for our customers. So the customer, the IT team decides what are the apps that should be available in the App Store for their developers, for their QA, for their data scientists, and those are the apps that are made available.
Okay, nice. And then follow-up question here from Bruce. He's asking about the time frame to architect a move of an existing application to Robin. What's it take to migrate an app? I'm sure it depends a lot, but do you have any general ideas?
Yes. Yeah. So at Robin, the typical migration could be less than a month, and the reason for that is we don't actually recommend, or we don't force you to refactor your application code. We don't force you to create microservices. We don't force you to change the entire application before you actually run it on Kubernetes. What we do is basically we use Linux containers. We will wrap everything you have running in, let's say, your SAP application or Oracle EBS application, and then we create the container for you, right? So it's not re-architecting the application itself, rather than just benefiting from the modern architecture that Kubernetes provides, and using Kubernetes and Docker containers, or rather Linux containers, we extend the benefits of modern microservices-based environment to legacy applications like Oracle EBS and SAP Business Suite.
Okay. And since Robin is just a software solution, I mean, it's only a software solution. You don't have to purchase hardware to run it on.
Yeah.
Or Robin's not selling hardware, I guess is what I'm trying to say. I would think it would be relatively easy to do a POC. How does that process work?
So it's a really simple process. Just get in touch with us. We'll help you through the process. There is a simple requirement where we have a prerequisite that you have to match, because even though it can run on any hardware, there are basically some hardware prerequisite. But that is a simple script you have to run, and once you're ready, you should be able to get Robin up and running and actually do the POC and get it into the hands of the end users within a week.
Very nice. Very nice. Sounds easy. All right. Well, I think that's all the questions we have. Great presentation. Thanks for being on the event today, Ankar.
Thank you. Thanks for having me.
For more information on the Robin solution, check out the handout that's in your audience console right there. It's a product brief on the Robin Hyperconverged Kubernetes platform. And now it's time to announce our final gift card winner on today's event. That's going out to Dan Soheda from New Jersey. Congratulations to Dan. And before we go, I want to remind you to check out the 10 on Tech podcast from Actual Tech Media. It's available in the iTunes store and wherever you find your favorite podcasts. If you're interested in sponsoring an upcoming MegaCast or EcoCast event, just email sales@actualtechmedia.com. We'd love to chat about that with any potential sponsors. If you'd like to register for future events from Actual Tech Media, visit our website, events.actualtechmedia.com. And speaking of which, our next event coming up is next Wednesday, January 23rd. It's the Cloud Solutions MegaCast. I hope that you'll join us for that event. It's going to be a great event. You'll see on the events website, we've got a lot of really great presenters lined up for that event. So make sure you join us for that one as well. I hope everyone learned a lot, and really enjoyed today's EcoCast. Thanks for joining. Have a great day. Bye-bye.